operation and planning. And I will highlight with the help of the so-called energy communities, which are rising very much, at least in Europe, which means that because the high variability of the generation, here is a pattern of the PV generation on our roof at the university. And you see, it's far away from that nice parabolic curve because we have a lot of clouds. And they are not predictable. I mean, and the movement, or let's say the variability of this PV generation is in seconds domain. So what we have here is 1 day recorded PV with 1 second reporting rate. But not only generation. If we will look, also the consumption is very variable, and is variable today also in the seconds domain. It's important to have the information like this. So one solution to deal with this unknown, unpredictable variability is so the first idea is to aggregate more such variable nodes in terms of power flow, and try to compensate between each other. And this would be an energy community. Of course, you cannot compensate perfectly, so you need to invest in storage. Unfortunately, even today, after so many years, storage is still very expensive. So we would be very happy to diminish the investment in storage, so to plan as good as possible for storage, so for this investment. So what does it mean? That we need to have information not only on generation but also on consumption with high degree of trust in that variability and in the model that we develop, because we want to plan accordingly. So we need this accurate load and generation profiles estimation. We also want to discriminate, is not the main topic of the talk today, but we want to discriminate between steady state and dynamic operation. Because when we see on a line this type of variability, we don't know if it is a abnormal operation or is just normal steady state quasi-steady state variability. So let's look further. How can we assess these issues that we have to face? So first idea would be to understand if it's really needed to know everything with so much detail, like 1 second reporting rate. What we have here is just a normal household power profile, and with blue to the left is recorded with 1 frame per second. So every measurement it's every second. And what we also have with red is an average over 10 minutes, over 10 minutes, and what we have with green is average with 1 hour. Why? Why 10 minutes? Why 1 hour? Because still these smart meters are deployed with very low, from my point of view, reporting rate. 1 hour, 15 minutes, 30 minutes. So we want to answer to the question, is it worth to put every second, to take every second information or not? Why we need this question? Because storing the information from 1 meter, so 1 node, every second requires 1.2 megabyte per day as a compressed file, which is not very low. So how to look to this answer? It is worth of. So one idea is to calculate the information loss. So for 1 day, to see how much information we lose if we use one value per hour or if we use one value per 10 minutes compared to this original highest reporting rate every second. And if we look to this household consumption, we have an information loss of 140% when we report every hour, and 30% if we would report every minute. The same household in another day would generate an information loss of 64% if we would report every minute. So maybe it's not good to jump from 1 second to 1 minute, and 113% if we report every hour. So it's a lot of information loss. So now the second idea would be, well, why shall we care about information loss? Because usually we have more customers, we aggregate more customers, so maybe their variability compensates somehow. And so we were looking to the best aggregation in this sense of customers, which is the student dormitory. We have dormitories with 5 levels, each level with 60 students. And we'll look for various days or on the in the same day with various levels, so various cohorts of 60 students. And we see that this variability doesn't compensate at all. Then we were thinking, well, maybe the trouble is not that big. So maybe it's not needed to go deep into this power flow variability. But let's look what is happening today, not only in Romania, but in the world. So because is this very good drive for installing renewables-based generation like PV, the distribution system operator became overwhelmed and they have to invest a lot to cope with this variability at low voltage at the customer side. Until now, we had variability only for the load conditions, and this was planned for more than 50 years. But now we have variability only in the other sense. So one idea is, and here is an example, to have 2 such prosumers connected between them in order to cope, to diminish the variability. Here is selected one DC link, and also investing together in a storage in order to diminish the variability. But what is very practical, and this is really encountered in many situations, the contract that we emulated here, but is in many countries very viable, with the DSO, with the system operator, is to act from this point onwards only as a load. So never 1 watt delivered towards the system, despite the fact that we have PV here and we have PV here. On the other side, we emulated, so for the other prosumer contract with the system operator, actually with a supplier, not the system operator, another contract which is less applied today, but hopefully will be of importance tomorrow, is to have a contract where we ensure a specific pre-agreed profile so that the operator can plan better, and of course the prosumer can also sell the electricity, not only consume, as in the case to the left here. So in this way, we already observed that by simulations that both load and generation variability plays a huge role in order to assess if such contracts are feasible, or how to invest in, how much to invest in the storage. Now, if we go back to that spatial aggregation that I already mentioned, with more energy users that might levelize the power consumption. Let's look to the campus. As I announced, we have those dormitories. We have several dormitories where we installed these so-called unbundled smart meters that are able to report every second, and we can look for one day in summer, weekday, how this consumption is looking and how much we lose from the information, as already announced, if we would record the averages every hour, and this is 51%, the loss of information, or every minute, which is 34%. To note that here the information is available with 2 frames per second, with 1 frame every 2 seconds. But the situation changed very much if we look to one winter weekday. And to understand, in Romania we have most of the time, and here is the case, district heating. So we don't use electricity for heating. The loads are almost the same in summer and in winter. Maybe in summer we have also air conditioning. And we see that in winter, if we would use 1 frame per hour, then the loss of information would be only 20%, and with 1 minute, 9%. Also weekday. So variability is much, much higher in summer than in winter. So this, again, why to assess this variability? Because we want to, for instance, to install PV on each student building, and we need to invest into the battery systems, and also we need to get approval for the DSO to have connected. And most likely this approval comes only if we are sure that we are acting not as generators or not as prosumer, but as a consumer only. So how to look now to this variability? One idea I already announced, to look to the information loss. But there are other ideas that can be borrowed from the estimation theory. And here are a lot of indicators, a lot of metrics to assess if an estimation is good enough for the reality, is fitting good enough. And you see a lot of them. What we wanted to say is, or what the idea was, to use into this estimation of variability without estimation, because we don't have estimated values, we have only real values, but to look if these metrics show better quality, so every second measurements, to a model that is assuming a steady state, so average operation, over longer time constants. And this is for the power flow. So what we want to calculate, how well the reality, every second measurements of the active power, is fitting to a model, which means constant power every 15 minutes or every hour or every 30 minutes. We mostly used 15 minutes, which is the smart meters today. If we would assess, or if we would use these metrics to assess the variability, not of the power flow, but for instance of the frequency, then the model would be a constant frequency every 200 milliseconds, which is the base for the power quality, for instance. So these time intervals to apply for these metrics are depending on the quantity, the model of the phenomena. But because the talk today is only about the power flow and not on the frequency, we will look to applications of these metrics to 1 second versus 15 or 30 minutes averages. And from all these metrics, we found out that most usable is the coefficient of variation of root mean square error. So this CV RMC is defined here. And also we studied the application of the coefficient of determination, which is R square. However, this R square did not meet our, let's say, our expectations to be used for power flow variability, because actually R square is a metric used to assess the predictive capability. Remember, they are all coming from predictions of a linear regression model. And actually, what is happening with the power flow for households, for energy use, not for industry, and for PV generation, which we studied, is far away for fitting a linear regression model. Yeah, so this is why R square, despite the fact that we use, is not very good. So let's look to some results. So we took just a power consumption, as said, in a household. We have the values every second, and then we analyze for 15 minutes. So what is the variability in terms of this metric CV, RMSE, and here they are actually, to convince you, all calculated. If we compare with the model, which is the averages over 15 minutes and averages over 30 minutes. And what we see is that the power of highlighting that something is happening in one moment of time has the highest power is this coefficient of variability of RMSE, so CV. I will use it shorter CV because otherwise it's too much. But then we look to the PV profile, a very strange PV profile, somehow showing us that actually it's on the roof of our university, but it was starting with a very deep shadow, and then with not that many clouds, as we see, and we saw that these points of variability are shown simultaneously by CV and R square. Well, here fitting, it's with regression model might have been worse, so this is why R square already showed something. But then we were looking, so first generation, then PV, but then we came to the case what happens with a prosumer that is not interested how variable is his consumption or how variable is the PV. It's very interesting how variable is the difference between generation and consumption. And this is the net power profile. And for real data, everything is real data. It's not anything, it's simulated. And this is real data from a real prosumer near Bucharest. It's part of our research programs, but it's just a real household and tiny business. And we applied, again, these two metrics. As I said, we selected them. And what we see is that both of them were very good in highlighting, this is the consumption, this is the PV, and we applied on this net power profile to highlight moments of very much, very higher variability. So we have these figures for one day on 5th of June and another day on 9th of June, the same prosumer, where we have strange generation profile. It was cloudy and raining, as you see, and both CV and R square highlighted, but CV already is highlighted all three variable here, and here, variable highly variability moments. So this is one approach that we applied to look into these metrics, to try to make a stamp, to put a stamp of the node, of the power flow in that node, either prosumer or only consumption, to say this is highly variable power flow. Pay attention, you have to calculate and maybe to invest much into the storage or even into the inverter for the storage. Or another way of putting the stamp is to apply multi-scale data analytics and to try to see when there are similar patterns, when appear dissimilar patterns like discords, and to relate, because it's much easier if we do like this, with the context. I mean, events can be a national day, can be a special day in that or special hour in that time. So to discard further from the variability. And here it's an example of applying matrix profile, which is one technique that proved to be very, very efficient to discover for such micro loads with high variability, to discover when there are similar patterns, motifs, and when there are most dissimilar patterns, which are discords. Here, just some information about the matrix profile that we applied for power profiles, but we did a lot of other applications. And for instance, in one day, if we have one day, we discover that the most dissimilar for the power consumption, not for the generation, is at midday, is this red point. And for 1 month, every second information, we discover that the most dissimilar, so the discord, is the first day. In this case, it was 1st of September last year, 2 years ago, sorry. So we can apply this multi-scale data analytics to understand the extremes of the variability for either generation or for consumption. And another way is just to apply very standard and not very elaborated statistics to capture the system dynamics. And I just invite you, if you want to look for such a higher network, to this paper in 2021, Transactions on Industrial Informatics. So it's somehow based on the or relates to the metrics that I announced before. They are coming also from statistics, but in a much straightforward way. Now, if you want to look further into compare dissimilarity, which is the result of matrix profile, for instance, in machine learning, versus variability as such, which is for the whole profile, you can go to IEEE data sets. They are all available, and you'll find there residential smart meter energy time series. So you have data from the residential for 1 month, and also you have 1 year student building smart meter energy time series, also with high resolution, which is 1 frame every 2 seconds. So you can play with this data. One way of playing and understanding visually the variability might be also in these graphs for 1 month, every day, how is evolving the power flow or the highest power consumption. It's a heat map. Or you can look in another way to this here only power consumption, which means detecting anomalies and rejecting them if we want to make predictions. So again, we assess the variability for various scopes. Now we move to make predictions. And if we want to predict this very variable micro load power flow, we saw that it's very variable. We can use extensive procedures like we saw based on the matrix profile, but we also can use the automated machine learning. And here is an example which has good results if it is applied also on data for which we removed the outliers. How to detect an outlier when actually, if we look to a power profile, in our mind, everything is an outlier. It's far away from a smooth consumption. This we did with median absolute deviation and constructing this interval based on 3 sigma or K, where sigma is a factor of K taken from the normal distribution of median, and then replacing the outliers, so what is outside, replacing with this value of with median. And so our goal was to find out if we filter in this way the outliers. Again, outlier is very difficult to understand if it's an outlier or not. Look to this power profile in orange. Is on 14th December. It's very, and if we analyze and we identify the outlier and these red points, and we clean the power profile from red points, and the red point becomes inside, and it's changed with the median, and this is the Hampel filter. Then we look to the estimation. How good is the estimation? And here with the automated machine learning, and this is a technique with AutoTS, we forecast for using the original, and we also forecast it with the filtered data. And you see that using the metrics for forecasting, we did not use until now, it's just to see them. Using the original data, the forecast is already a little bit lower in quality than using the filtered data. Now we see the errors lower. So this means that filtering, discovering the outliers, was working good, despite the fact that is difficult. So to close up my talk, we saw that we need a new paradigm and for control in emerging power systems, and this is especially because it's lower inertia, so we need higher reporting rates information. We saw that is the power flow variability. If we want to look at it, then we have to request high reporting rate or high communication rate from the measurements. If we don't request that, we might be very happy to see a smooth and not very variable power profile. So who is capable to give us the information with high reporting rate? These are the new generation of smart meters, or the, how we call them, unbundled smart meters. But of course, we can request for any other device able to give the power information and not the energy information. Still, the companies, the supply companies, issue a bill for the energy consumption, but I think that very soon the bill will be incorporating a lot from the power. And this we see, for instance, for power connection of prosumers. Then we looked into some measures of variability. The first one is the information loss, but we proposed to use two measures coming from the estimation theory, and they are applied on time constants or time interval constants linked to the model that we want to analyze, and in power flow is the 15 minutes. Then we look to apply them to the net power flow variability, which is one good idea if we have prosumers, so not separate, but to analyze if the variability of the power consumptions matches or is just in the other direction with the variability of the PV. Then we look into some elements of data analytics for low inertia energy systems. What does it mean that we look to this micro load forecasting analysis and forecasting, so not aggregated. And then we looked at, despite the fact that discovering outliers is very difficult, we can do it with that proposal with sigma, around the median, 3 sigma around the median, and this forecast based on outliers filtering is better than the forecast using the original data. What we did not apply yet is a link on how to filter based on the pre-analysis of the variability of the power flow. And with this, I ended my talk, and I'm waiting for your questions. Thank you.
So, hello. Am I audible, Professor Alvo?
Yes, I hear you. Yes.
So, thank you for giving such a wonderful and informative talk, right? And we are thankful that you have joined for this RDK 2023. So, while going through your presentation, it was very informative and useful, like data analytics, paradigm of the control, and filtering aspects that you have mentioned, and measuring variability. These all are the very pertinent aspects of the power system engineering and for the measurement aspects. So I'm thankful that you brought these all the terms and topics in front of me and my colleagues and my students. So it was loving that we got this opportunity to hear you, and we are thankful for your association. So thank you, Professor Dallu. Thank you. It's over to you.
Next, we are highly honored to have with us Dr. R.N. Patel, sir, as an invited speaker. It is an honor to introduce Dr. R.N. Patel, sir. Dr. R.N. Patel is an associate professor at NIT Raipur and currently is serving as professor on deputation at CSVTU, Bhilai. He did his PhD in the area of power systems from IIT Delhi in the year 2003. He received his MTech from IIT Delhi and graduate degrees in electrical engineering from SGS ITS Indore. His manifold fields of interest include programming and optimization, application of artificial intelligence techniques, power system stability, and renewable energy systems. He has presented his research at various international journals and conferences and organized many tutorials, workshops, and conferences. He is a senior IEEE member and has many research papers in transactions and SCI journals to his credit. Dr. Patel is a recipient of the prestigious Career for Young Teachers from All India Council for Technical Education, New Delhi. He has also authored a book, Programming in MATLAB, a problem-solving approach with Pearson in 2014. Now, I request Dr. R.N. Patel, sir, to enlighten the audience with his worthy words. Sir.
Yeah, thank you very much. Am I audible to you? Just wanted to check. Yeah,
Yes,
can you hear me?
you're audible.
Yeah, thank you. So let me share my screen. I hope I'm allowed to share my screen. 1 second. Yeah. Can you see these slides?
Yes, sir, it's visible.
Thank you so much. Thanks for inviting me to this RDCAP. It's pleasant to be always to be with the MIT University. I have been there physically also 2-3 times, and it's a pleasure to see all of you. I apologize for not being able to present on physical mode, but it's a new mode of meeting. I hope you're comfortable. This topic is, please, I just request the coordinators to let me know the time 5 minutes ahead when I have to finish, so that I'm conscious about the time. Just give me a message as about when the time is going to end. What is the time given to me? Can you tell me, please, approximately?
Sir, 20 to 25 minutes is the time limit.
Right. So I'll finish by before 1 o'clock. Okay. I mean.
All right, sir.
5 minutes before the 1 o'clock. Okay, all right. And also, please let me know if there is any issue with the audibility or visibility of my slides. So I assume everything is fine. Can I go ahead?
Sure, sir, you can go ahead.
Thank you so much. It's a very important topic today. We are here to discuss the topic of use this. All right. Yeah, the topic here is unlocking India's clean energy potential and opportunities and challenges, right, in this green energy application deployment in India. So it's a very important topic. It's close to my heart. I do research in this area also, and I guide PhD students in this same area. So we'll talk about how the green energy potential is increasing in India. However, there are certain opportunities as well as certain limitations and challenges, some constraints. So this slide will give you an idea about all those things, and it's very useful to all the people, including common man. So India's target of solar, particularly I talk about solar energy. When I talk about green energy, my focus will be on solar energy because that is the most promising for India and also available throughout the country. So India's target of the solar increase all the way from 22 gigawatt to 100 gigawatt to 300 gigawatt. So actually it all began with the Jawaharlal Nehru solar mission, which was launched in 2010, and the target in this mission was 22 gigawatt of solar power by 2022. But much before time, in 2015, Government of India already achieved the target before time and increased the target to 100 gigawatt by 2022 in 2015. Again, 2020, the government announced 450 gigawatt of renewable energy, out of which 280 gigawatt would be solar by 2030. And there have been a very important conference called United Nations Climate Change Conference, COP. It happens every year. So in COP 26, the Prime Minister Modi announced the target of India for this renewable to be 500 gigawatt, and out of which 300 gigawatt would be solar energy. I'm giving the data to you because to understand the potential of green energy, particularly the solar energy, right? So total electricity installed capacity by 2030, by the current this year up to March, was 417 gigawatt total electricity capacity of India, out of which only about 173 gigawatt is renewable so far. So approximately 42% of the total installed capacity. And by this year, we had only around 67 gigawatt of solar power. So it is only about 16% of the installed capacity. And this data is very important because we have announced to reach to about 50% of the installed capacity by this 2030. So from 16% to 50% journey is a tremendous opportunity. Okay, so this whole 67 gigawatt has been the solar power till the current year, and out of which the rooftop solar power is about 7.5 gigawatt. So the coal still plays an important role. It's about 49% of the total capacity of India. So coal has to be phased down, but you cannot get rid of coal. That's the status of as of now. So now India's commitment in 2027, in 2022, in 27th United Nations COP conference is that we will increase our 50% renewable by 2030. Out of which I just mentioned that the previous slide, we have reached only around 42. Renewable is 42% of the installed capacity. So we have to go to actually net zero emission by 2070 and 50% renewable energy by 2030. So this is the status. So this 50% commitment of renewable by 2030 and net zero by 2070 gives a lot of scope for the proliferation of renewable energy, particularly the solar energy. What will be the potential economic opportunities? If you see this target of 2070 and 2030, we'll have a lot of investment, a lot of revenue generation, a lot of government investment as well, and a lot of employment opportunities. Very important for us. Lot of different kinds of jobs opportunity. I'll be discussing about these things in my future slides. That we have tremendous opportunity for green sector jobs, green jobs. So there is a positive impact and ripple effect on the economy and society, because it's not only economical development. This green energy sector gives you opportunity also for the environmental, conservation, and also social development. So these are the opportunities. This is a very interesting slide. It talks about the installed capacity of solar power over the years. Solar power PV systems, right? So from 2010, 2010 still to 2020 is data, and this says installed capacity has been increased. It was a little bit down in the COVID time, as you see in the red bar graph. But if you see the blue line, this is the total capacity, and it has been increasing year by year, almost doubling every 2 years. So it's a log scale. So and interestingly, the cost of electricity by solar has gone down tremendously. In 2010, the solar power cost per unit electricity was 12 rupees approximately, and has come down to about 2 rupees commercially in the commercial sector in 2020. So it is actually bidding. So these are not for the small consumers. These are for the large producers, which give installed capacities in hundreds of kilowatts and megawatts. They are able to offer this low price of electricity. Okay, so this is the cheapest power. Solar is the cheapest power. So we need to still go a long way. I just mentioned that we have reached to only around capacity of 67 gigawatt, and the target is 67 to 300 gigawatt is the target for solar. So this is still a tremendous opportunity. Why solar power? Because it's clean, sustainable, and it can serve off grid. It doesn't require transmission lines. It is highly scalable, right from your 1 kilowatt plant in the rooftop to megawatts of plants are still available in India in many places. So very fast to implement, because it takes only around 3 to 4 months the total installation, even if it is in megawatt capacity. And as I just mentioned, that around 2 rupees is the minimum price quote by the large producers, and 50% installed capacity by 2030 has to be reached by renewable sector, and reduce the total emission by 1 billion tons. It's a tremendous reduction in the pollution in terms of CO2 emissions. So by mid of 2022, India was the only G20 country which was meeting the target. Okay, it was the only country as per the announcements in the COP conference. Sorry. So solar energy provides energy security for India. We are very blessed to have more than 300 days of solar power in most of the part of India, in out of 365 days. So what is the reason for this proliferation of solar power is that we have got a reduction in the solar modules, the cost of solar modules, this graph shows in dollars, how over the years the cost of is exponentially reduced. The cost of solar modules is exponentially reduced. This is the right side graph shows the different components, including the module, the inverter. One of the major reason of solar power proliferation is that power electronics industry has developed a lot, because solar means power electronics. You have to have a DC-DC converters, you have to have DC to AC, inverters, and so on. So all those things have reduced tremendously, as you see in this right side graph. So this is the reason for increased adoption of solar PV systems. Sorry, module cost. Just give me a moment, please. Okay, so module cost has is reduced a lot, because there have been a lot of alliances, lot of collaborations among the countries also. So still among all the components, you see this, the module cost is still higher. If you see this right side graph, module, inverter, there are different components. This particular slide shows the different types of components in this thing. The most important, of course, is solar modules or solar cells, which is actually shown here in the center. If you see this, there are a lot of other components, which including the aluminum frames, the glass covers, the back sheets and junction box, and so many things. So all these are different industries, out of which we are shortage of solar cells. We are having dependence on China and imports. Therefore, the module cost is still higher, particularly in India, but also across the world. The module cost is highest among all the components. So approximately 350 to 500 watt is the power rating of each solar module. As you see, this is one module, consists of many cells. So approximately it's going to, and the good thing is that over the years, the module capacity in the same size, the power rating has increased, and from 350 we are now talking about 600 watts of solar modules, and efficiency also has increased in the range of 15 to 23%. The total overall efficiency of power conversion from the solar. Global deployment of solar. This is a very important slide. This is a slightly old data to 2022, in which the India was ranked number 4 in terms of total installed capacity. Ahead of us are the USA, Japan, and Germany. These are different countries' solar deployment, but India is going ahead much faster. We're very proud to say that the largest power plant of the world in solar PV is in India, and the top among the top four power plants, 2 are in India. So the topmost one is the Bardla Solar Park. Is now they talk about solar parks. Okay, solar parks are huge power plant establishments. Like in Bardla, it is okay in Rajasthan, I understand. So this is 2,700 megawatts in one place. You see the skyline view in the right side. And the next one is Pavagada in Karnataka. It is almost a 2 megawatt of power plant. This is 2.7 megawatt of power plant 2,700 megawatt of power plant. This is gigawatt, right? 2.7 gigawatt and 2 gigawatt. These are 2 power plants. So if you see the closer view, this is 2.7 gigawatt in Rajasthan in Bardla. It's the largest. And this right side of the picture is, I understand, is from the Saktisthala power plant in Pavagada in Karnataka. It's a huge establishment of 2 gigawatt of capacity. It consists of around 13,000 acres in 5 villages in Karnataka. And a lot of people and villagers are also given their land. Farmers are given their land for this cause. So in fact, they're very interesting to tell you that there have been a lot of barren lands are being converted. Chhattisgarh government, I stay in Raipur, Chhattisgarh. Chhattisgarh government has announced support that if you have your own farm, the farmers who have some kind of a not so good farmland, they can use it for power plant. And government has already given a scheme that you can connect and you can export your power, you can to the grid from your farm. So government has facilitated in Chhattisgarh and I think in many other states also the the rural grid, which is connecting to the farmlands. So there you can connect to the nearby substation and export your power to the grid, and you can earn money from the land which is not so useful for the farming. So there's a lot of water scarcity. So in places where there's less water, they also can go for solar farming. So many farmers are shifting to solar farming. Just a case in point. There are a lot of already discussed some of the things about opportunities, but there are opportunities for transition to green energy, opportunities for rural areas, which I'll talk a little bit more in detail, opportunities for job creation for the students and for entrepreneurs, and startup and innovation culture. I am promoting startups in the energy sector in Chhattisgarh. Apart from that, there are challenges, which are dust. Major challenge in India is the dust soiling problem. A lot of dust deposition happens. So therefore, these are some major challenges: soiling or dusting, land availability. If you go for megawatts, you have to have land. Storage is another challenge because you cannot store solar power. It becomes much more costly when you store the power. Most of the power plants which are commercial are on grid. They do not have battery storage. And manufacturing is a challenge because we do not have sufficient silicon for the solar modules. And solar waste is a very important sector. How to deal with the solar module wastage. Now, this is some of the transition to green energy. Basically, it is a very essential because a lot of places there have been, like CC Delhi itself, a lot of problem of pollution in not only in Delhi but in different Germany, in Canada, and so many places there have been climatic changes in the result of uncontrolled CO2 emissions, and therefore it is important to switch to solar. Some of the things which are for the employment sector is so you see here there are a lot of rural employments. For example, this is solar charkha. Charkha is Gandhiji's famous this thing. You all know that. Now the charkhas are run. I have personally visited. Is Wardha, where Mahatma Gandhi himself lived. There are a lot of looms which are run by solar energy, totally, and automated. They are working on the solar looms. And Chhattisgarh is the state where highest number, I think 1,20,000 solar pumps are installed in across of in one state alone. Chhattisgarh has highest number of solar pumps. So farmers, even I have my own farmland where I have 2 different solar pumps. So these are available under very subsidized prices, and government is trying to promote because the farmers are using electricity which are free of cost. So government tries to save the electricity, and there is not infrastructure. There is no infrastructure in the farmland to lay down the electrical line. So for irrigation purposes, the popular trend is to go for solar pumps. And we did some research also with the University of NC State along with NIT Raipur on the potential of the solar pumps in India. So now actually there have been a lot of job creation. Talking about jobs, there have been a lot of job creations. Excuse me. This is a off-grid modules, particularly for the rooftop. There are a lot of technicians which are required. There is a new policy called net metering, where if you have 1 kilowatt plant also, you may export your power, extra power, because people who are working in offices, like all of you, most of you who are in Noida, they have to, the whole day they're working. So you have solar power plant at your house, whole day you can export your power to the grid, and you do not have to have the battery. So the amount of power you export to the grid, that means you can become power producer. There is a policy in almost every state, net metering policy. You can export the power when you do not need it in daytime. In the night time, you can import the power from the grid. So net meter is basically difference of the two will be your billing amount. So that's what is a great opportunity, because you don't have to have battery systems, battery storage. So the solar rooftop size, as I said, even from 1 kilowatt, they are now allowing to export to the grid. So there is a lot of potential for the solar rooftop. It's attractive for commercial establishment in colleges also. and also in individual houses, right? And there's a lot of job creation because people are not there, sufficient technicians are not available. NSDC is National Skill Sector Council of India. It offers many different skilling trainings for the solar technicians. And it's a need of the hour. Still, because the rooftop capacity is very low even today in India. Now, what are other green sector jobs? Could be many. This is a slide. I'll go a little bit fast. Green sector jobs are those jobs which are promoting green energy. So those include managerial jobs and technical jobs. So these are different skill jobs like renewable energy engineer, technician, and sustainability manager, consultant, green building architect, designer. These are technical expertise. And managerial side, green supply chain manager, green marketing specialist, waste management professional. Very important because once you have the let's say green energy installed, you will have to deal with the waste management from the modules and from battery and so on. So for that, there is a need for professionals. So all these are green sector jobs. Now, what to do as a student? What one should do to prepare for these kind of jobs? Because all of us, most of us are working at the colleges, so we can encourage our students for the following 5 points. Encourage them to have practical experience. Go for internship. We all have summer training, so let them encourage them to go for summer training in some kind of solar power plant or some sort of manufacturing industry, but solar modules and so on. So that's one, gaining practical experience through internships. Participate in extracurricular activities for the students. If they want to go for green sector jobs, these are important things for their resume building. So extracurricular activities could be events, this kind of conferences, and some kind of workshops, and also their own hobbies, right? 6 certifications. There are, as I said, NSDC has its own certification. There are many bodies which are giving certificates in the solar, like solar energy technician, solar energy manager, and so on, including BEE, Bureau of Energy Efficiency, has energy auditor, energy manager, and so many opportunities for certification programs. Showcase the projects and portfolios. So encourage the projects demonstrations at the green sector because society needs that. So projects can be BTech projects, MTech projects could be there. Green entrepreneurship. I am particularly working on this one. Entrepreneurs who can deploy solar for. I have many ideas to how to deploy these things. And as entrepreneurs, you can give startups grants to the solar entrepreneurs, right? And not only solar. I'm just giving solar is a focus area today, but any other green sector. But typically, solar has a lot of potential. Startups have many potentials for many areas. Startups could develop new materials, like they're talking about now organic solar cells, okay, which will be it will not have any problem of disposal. So made of organic materials, organic solar cells. These are different technologies. People are working on that. Manufacturing processes to make roll to roll. Like there's a process to make a thin film kind of solar. Thin film. There are different technologies coming up. So you can roll up your solar sheet and install in windows and many places, right? So in buildings. Power electronics is a major sector where a lot of research is going on. So power electronic converters can be more efficient and more cheap, cost effective. Power plant monitoring. So you can have drone-based monitoring. All this can run by solar. Different kinds of power plants and different industries. You can have drones which are working on the solar. I think there was I think 2 years back, there was a news for completely, green flight which travel around the whole aeroplane which travel with solar energy across the globe. So that kind of things can be designed by startups and innovators. Surge in the startups. So a lot of startups already are working on that. So these are some of the startups which are very popular at the global level, which are working in the energy sector. Some of them are millions of dollars of turnover. So actually, why students will start a business? So actually, students will start a business, particularly green business, because there's a lot of learning opportunities. Ecosystem is very friendly. A lot of, I'm sure MIT also has incubation center. I know about that, but there is a A lot of grants and government has a lot of seed funding for the startups. Learning opportunities. If the people are going for internship in startup domain, they will have a lot of learning opportunities. Some of my PhD students who graduated from Raipur, they have already joined green sector industries as per the jobs. And the startups they've joined the startups for the jobs. Flexibility, a startup has flexibility for the time. Also, all of us are fed up with the modern kind of job which are not so flexible. So you can think about starting a business, particularly in green sector. Personal, professional growth, long-term career prospects. So these are, all of us know about it, but it's the right time. Today is the right time to start because a lot of things are supportive. Okay, a lot of investment, a lot of investors, a lot of government support, a lot of seed funding. Only thing we should have is sustainable, marketable idea which is commercially successful. So that's what we have to work on. A lot of other things for entrepreneurship, which is manufacturing. These are some examples. You can manufacture LEDs, you can manufacture the solar fans. These are still costly. DC fans are very much cost effective. Very much energy efficient, but not so cost effective as of now. So we can reduce the cost of DC fans. Okay, so that will be another thing. Similarly, solar structures, solar pumps, inverters, all these are manufacturing segments. You can, if you don't want to manufacture, you can be an entrepreneur in the dealership or distribution. You can have, they can take leadership or become a distributor for solar inverters, solar pumps, DC fans, and so on. Home appliances are very important. Nowadays, a lot of home appliances are DC appliances. There is a talk about DC homes. So there's a future for DC homes, and you can have dealership to have total solution for the DC houses, especially for the remote places. And not only for that, but even for cities, a lot of efficiency can be achieved by DC homes. And you can also become system integrator. If you want to have your own company, you may be, you may enroll with the corresponding local body and become a system integrator. System integrator are those people who have government, affiliation to install solar systems and so on. So you can connect with the government to become system integrator. This is a video. Actually, I don't have time to play the video. I can share the slide with you. This talks about, sometime back I talked to किसान की बंजर भूमि बनेगी आय का साधन. This is a Prime Minister's Kusum Yojana, right? So this is you can have solar farms. This video shows about success story of some farmers who have gone for this Kusum Yojana. If you want to know more about it, you could go for the Kusum Yojana. Right. Okay, it's fine. So now let's go ahead. 5 minutes to wind up. These are the opportunities. I think I talked enough about opportunities. Now quick overview about challenges. Already mentioned them. Opportunities, challenge is also an opportunity, by the way. Every challenge is an opportunity. Soiling or dusting, you can have solar cleaning systems. So robotic systems, these are some examples of how not to clean. People are not having sufficient ways to clean the system, therefore efficiency is down. So there is a lot of need for robotics and waterless cleaning, right? Similarly, land availability, for that you can use the ponds and the canals and so many things. Prime Minister Modi, way back, he installed one of the first floating canal-based plants in Gujarat when he was the chief minister. So these are the dams, and there's a lot of advantage of floating. This is, by the way, this power plant is over a dam. So floating structure has to be designed, and it needs research. So this means there is a lot of scope for this kind of structure which saves the land area, and also it conserves the water because evaporation is less, and it is good for the solar module also because they remain in the cooler atmosphere. So in all the ways it's good. Only thing is the cost factor, which is for the solar floating structure. That's one way to solar buildings. You can have a lot of but then there is a issue of shading and so on, so you can tackle with that how to design architectural based buildings. This is also challenge. It's not so easy to design solar buildings. So in Raipur, there is a CREDA which has complete net zero building, which is the whole building is solarized. So people are now going for net zero building. Okay. Agrovoltaic is the new major field to save the land area. There's a Some plants grow in in some shady atmosphere, so you can also have agriculture and photovoltaic in the same farmland. So that's another area. Storage of this thing, so you can have hybrid things. The solar cannot be stored, so in the night time, you can solar, wind, and combination hybrid system can be designed, and then the cost factor can be optimized for this kind of hybrid power systems. All right, so this is to avoid the storage problems. Manufacturing in solar in India is another challenge because we are dependent on the solar modules. 85% of our modules are imported from China and other countries. So we have alliances. I'm going to just wind up in 2 minutes, please. Okay, right. Just solar manufacturing. There have been solar alliances. Different countries have combined together, and government is giving certain incentives also if you have solar manufacturing plant in India. So these are some of the Adani's power plant. This picture shows under the Atmanirbhar Bharat. There have been a lot of incentives by the government. This is Vari's power plant, right? In this way, I was talking about alliances. Many countries have formed solar energy alliances, and then there have been agreement to support each other to manufacture. There have been 101 signatory countries. India is one of the major countries in ISA, International Solar Alliance, to support each other for manufacturing of solar modules and so on. Solar waste disposal is a challenge also, where a lot of startups are required. Unfortunately, the raw material which is recovered, the different ratios. This slide shows, there was one slide here. Yeah, this slide shows the glass percentage is 74% of total weight. Aluminum is 10% of the total weight of the module, and silicon is 3% of the total weight. Silver is only 0.006%, but value-wise, it's 47% of the cost of the module. Basic, I mean, it could be recovered, right? So this way we have the challenge is that very small percentage of this silver can be recovered, which is especially used for the joints. So this is the different kind of industries can happen in this recycling of the solar and the reuse of the solar modules. These are the opportunities as well as challenges. Solar scrap is a major challenge. How to deal with the solar scrap? Last few slides. MNRE is the national body for Ministry of New and Renewable Energy Sources. We have a lot of schemes, including I just talked a little bit about solar pump. You can also have idea about module-wise cost. Different kinds of government has made a standardization of everything. So anybody can start a business or enterprise and refer to the MNRE for the resources. They also give tenders and a lot of other things, documents and previous projects and so on. Every state also has MNRE's corresponding, this is MNRE's website, corresponding MNRE's corresponding state nodal agency. In Chhattisgarh, it's called CREDA, and in other states also there are different, these are different states nodal agency. If you want to go ahead, if you can just go to see this thing, so one can contact the nodal agency of the state. Last slide is green energy transition is very important to avoid global warming and climate change, and solar PV is very much promising for 3 decades at least. Okay, and India is having a lot of role in the international level to become a solar hub, and a lot of semiconductor manufacturing innovation startups are possible. R&D in power electronics, recycling, and all these things are very important. So with that, I think already exceeded my time a bit. Thank you all for your kind attention. A very good thing is that green energy jobs are there for the students. Thank you so much. I'll end my slide with this. I think you don't have much time for the questions, but if you have just one or two quick questions, you're welcome. Thank you. Was I audible to you?
So this is Sinha.
Yeah, yes, sir. Yes, please.
Yeah. So you have given a wonderful talk on clean and green energy, and with a lot of applications you have shown to us and to the students also. I mean, there are a lot of opportunity for startups that we have seen from your slides. Government is also giving a lot of emphasis on solar side as well as EV. Also, EV adoption, I think, is going to help. I mean,
yes.
This solar sector with the this impetus on this solar sector, EV is faster adoption of EV is also going to be there, and there are challenges in implementation of the solar sector. But
Yeah.
I think I mean gradually the shift will be there in this side. So thank you, sir, very much. And we are running out of time, so
Yeah, I understand. I
we
understand.
will have some questions later on. We can connect with you. Okay.
Yeah,
Thank
sure, sure. You're
Thank
welcome. I'll share my slides for the reference. Thank you so much. Thanks, everyone, and have a nice learning experience in the conference. Thank you.
Moving ahead with the session, it is an honor to have with us Dr. Wahid Nasab sir as an invited speaker. It is my privilege to introduce Dr. Wahid sir. Dr. Wahidi Nasab is currently Director of NTU Grid Lab and an Associate Professor of Power and Energy Systems at Nottingham Trent University, UK. He is also a Research Impact Champion for Engineering and Computer Science at School of Science and Technology and a member of the NTU Research Impact Strategic Oversight Workstream. He has 2 decades of experience as a power and energy systems researcher and academic and has worked on various interdisciplinary projects. Before joining NTU, he held leading research, academic, and management roles at EPSRC National Center for Energy Systems Integration and Active Building Center at Newcastle University. He also held leadership roles at NERO Electric Power Research Institute and Shahid Beheshti University. He has published numerous books, book chapters, journals, and conference articles and serves on the editorial board of several international journals. He has a remarkable record for attracting significant external funds and effectively managing large scale industry projects. In addition to his extensive involvement in 13 large and complex national and international projects. Now, I request Dr. Wahid, sir, to enlighten the audience with his words. So,
thank you very much for the introduction. Good afternoon, everybody. It is a pleasure being here, and thank you from the organizer for inviting me to this one. I now start my presentation. The previous speech was on the renewable integration, and I realized there are plenty of great opportunities in India and plenty of advice on the startups and importance of the young generation for the next part of the system. So I will continue from that point that we have plenty of challenges in the power system because of the integration of renewables, but it is inevitable. We have a more serious challenge on the climate change we need to face. So we just need to find how we are able to face it and what are the solutions that we can increase the hosting capacity and operation within that situation. And I know that there are plenty of opportunity of solar with a high generation rate in India, and it is very important that young generation start working. And I will continue on one challenge of integration of renewables and changes in the climate change, which is cascading failures. So the topic that I will present today is on operational resilience in future power grids, cascading line failure localization via tree partitioning. So the studies that I do on this topic is in the Grid Lab, and as introduced by the presenter, the Grid Lab is within the Nottingham Trent University, and we have one motto for our research there: resilient energy systems for people empowerment. We are thinking about solutions that can support societies and people around the different technological development. We think about people and how we are able to help them in this transition toward net zero, toward the development of integration of renewables and the other areas. So to have this topic, I will present today, and I hope that by the end of this session you can learn a last resort action for these kind of challenges. I will answer a couple of questions within this presentation to reach to the end point. The first one is, what is cascading blackout? and what are the examples? For those who have no background on this topic, I try to explain it in brief. What is controlled islanding and disadvantages? A traditional and conventional approach to face the blackout and imminent blackout. And I will highlight what was the disadvantage of this mechanism that we forced to present a new approach to that one. Then I will provide a definition on three-partition network, how it can be used. We'll test it on a system under study, and then provide you some unanswered questions for future direction of researchers if you are interested in this topic or you are researchers in this area. So let's start with the first question. Cascading blackout refers to the intrinsic characteristic of the power system. Transmission networks are designed to be meshed and operate in the mesh system. There are many parallel passes or loops from a point A to point B in the power system, and it is very good for reliability point of view, but it has some problem. If one line trips, other lines may get overloaded, leading to a cascading large area blackout. So while we have a good opportunity from reliability point of view, but in the practical situation, when we have a situation, then it can be a bigger problem of cascading blackouts. N-1 reliability criterion states outage of a single element should not cause overloading of the other elements, but cascading blackout happens when one or more disturbances happens, and this can be by a nature caused, computer or human failure, or even a cyber attack. There are plenty of examples of cascading blackouts, and I provided here an updated information from a recent paper in IEEE Power and Energy magazine. As you can see here, among the 12 largest North America power outages since 1965, 8 of them was a cascading failure. So this is a frequent elements in the studies in the power system that we face, and I heard that there are plenty of examples in India regarding the cascading failure that attract and need attention. So the question is that how we are able to face it. In the traditional and conventional power system, I can see that the controlled islanding attracted attention. There are plenty of papers and publications in this field, but we found a number of challenges and issues with this method and this approach. When every other effort in keeping the network safe fails, to stop a cascading blackout, we use controlled islanding by splitting a network into a number of islands to keep it safe and prevent from a spread of a failure to the rest of the power system. Each island is well connected internally and weakly connected to the other islands and contains only coherent generators. Islanding requires tie lines disconnection, and generally the islands are not power balanced, so balancing actions or load shedding are required. These are specific characteristics of controlled islanding. So we need to disconnect the whole network in a few islands. Then we have weak areas that connected just to keep the network safe. But what are the problems with this approach? Despite significant research efforts over the last 20 years, there has been no repeated practical implementation of controlled islanding. When we are talking about a mechanism in the power system or a research, we need to see what is the impact, who will use it. If we have a mechanism that over the past 2 decades, no one and no operator use it, then there is a challenge. We need to think about new solutions and see what was the problem that the other didn't use it. Islanding is against the fundamental instinct of system operator, who always try to keep the system connected together. This is the main reason that operator doesn't attract to this mechanism and never use it. Balancing the islands will require load or generation shedding, and that means that more customers would be affected and disconnected during the islanding procedure. A large number of tie lines linking clusters must be cut, so a big shock to the system will happen and will cause some stability problems if we are not careful about it. After the event and when everything is cleared, now we need to reconnect those islands. So a resynchronization action is needed. That's another problem we will face. There is the risk of unnecessary islanding, and orally I can say the cure could be worse than the disease, and this is the reason that controlled islanding didn't attract attention by the operator and never applied in any areas around the world as a practical solution. Seeing these weaknesses and challenges for controlled islanding, we thought about a new approach that can be selected to solve some of those weaknesses and disadvantages. And it was there that we found tree partitioning from the mathematical and computer science area and brought it to the power system. So let's define the tree partitioning and see how we approach to this method and how we use and show it can be helpful for the power system. The start of our research here was from a work by Stephen Law from Caltech University. Stephen Law and his team in Caltech provided a mathematical approach, and they provided proof that instead of disconnecting all tie lines connecting a cluster to create islands, we can retain one tie line, which is called a bridge, such that the cluster level graph form a tree. So if you can look at here, we can see that in part A, we have cluster level graphs. And if we convert it into the tree partition system, we can see the graph B, which is totally in tree form. There is no loop there, and this is the start point we use. There is no loops in the tree partition network, and therefore only one path between any two clusters exists. So now let's move on and see the proof that's provided by Stephen Law about tree partitioning and how it can localize line failure. Caltech team used a spectral analysis of the Laplacian or admittance matrix and Kirchhoff matrix theorem, generalized line outage distribution factor or GLODFs, that quantifying how much a power flowing in a disconnected line will flow through other lines. And they proved that for a non-cut set outage, it means a line failure within a cluster, GLODF, the generalized line outage distribution factor, is block diagonal. From mathematical point of view, being a block diagonal matrix means any line trips inside one clusters or non-cut set outage do not affect power flow in other clusters. It means line faults are localized, do not propagate to the other areas. So it is very mathematical approach. We face a few questions here. Is this meaningful and feasible from a power system point of view? How to decide on the cut sets? And what are the applications in real-world power system? So when we face this mathematical approach, we ask these questions. We had some discussion with Stephen Law and the team in Caltech and started to make it ready for power systems. I am a power system researcher. My colleague Janusz Bialek is a fellow of IEEE and a power system researcher. And most of the time when we face a problem from any areas, we face how researchers in our field can use it, how we are able to interpret it to a language that our community can use. So we started with a physical explanation of fault localization property of tree partition network. The proof provided by Caltech was mathematical, involving graph theory. A simpler proof here based on physics provided by us, considering a simple tree consisting of two clusters connected by a single tie line or a bridge. So we have a cluster A, in simplest form, a cluster B, and there is only one tie line in a three-partition structure. The flow of power between these two clusters, PAB. So the only way that one cluster can influence the other would be through this tie line between the two areas. If they stay constant, a fault is isolated. So power transfer from A to B, which is called PAB, depends only on power imbalance in each cluster. So every export from area A will be an import to area B. The PAB does not depend on the internal connection within each cluster. So it is a flow of power between two areas. What is the reason for transferring power? Just the imbalance. And if there are no generation or low trips in an area, a line trip in one cluster does not affect power flow in the other areas. Now I use this topic and this simple example and generalize it to a three-partition network with any size. So we use from Kirchhoff current law to prove this concept. From the Kirchhoff current law KCL, we know that P is equivalent of C multiplied by F, in which P is vector of n cluster imbalance or injection at three nodes. So if we have, for example, a three node like the one provided at right hand side of this slide, every node here represented in matrix P that shows the injection to the nodes. C is cluster level n by n minus 1 incidence matrix that shows the topology of the three-partition network. And F, a vector of n minus 1 bridge flows, shows the tie line flows between different areas. So based on the KCL, on this simple network, we know that P is equivalent to C multiplied by F. As a graph is a tree, C has a full rank equal to n minus 1. So C transpose C is invertible based on the simple math. Bridge flows F are unique and can be calculated based on the more Penrose pseudo-inverse approach. So F will be C transpose C inverse C transpose multiplied by P. So we can see here that the flow of powers in the tie lines F just depends on tree topology, which is depicted here by matrix C, and cluster power imbalance P, but not on the internal topology of each clusters. Which this simple generalization, we could generalize our idea and the localization that if we have a three-partition network, we can prevent cascading failures to spread to the other areas. Let's move on and see what are the advantage and application of this mechanism. In the initial mathematical approaches provided by Stephen, they suggested that network should be permanently three-partitioned to prevent any future cascading blackouts. But we found it a bit risky, because this would permanently weaken a network, leaving some line not utilized. Not n-1 secure, so in most of the time we have a very serious problem with n-1 security. Any challenge in the tie lines would cause a serious problem in the power system, so unlikely to be adapted by utilities and operators. So instead of that, we suggested that using three-partitioning as an emergency measure, similarly as control islanding when a cascading blackout is imminent. So our solution is to use three-partitioning just at the time we have imminent blackout. We expect a temporary emergency measure rather than a permanent one is more likely to be adopted by utilities and power system operator. So what are the advantages of three-partitioning approach we provided here than the control islanding? While both tree partitioning and controlled islanding achieve localization of line trips, for tree partitioning the bridges stay connected. So the network graph is still connected. Power transfer between the clusters can still take place, subject to the capacity of the bridges. Reduced need for power balancing actions. It means load shedding is reduced. Fewer tie lines are cut, so smaller shock to the system will be imposed. No need for resynchronization, which is a serious problem with the control islanding and more likely to be accepted by industry. So these are a number of advantages we found for the tree partitioning, and we see it can be a greater options for the future power system when we have imminent cascading blackouts. Let's move on and see the implementation of the idea and the test results. To test our idea, we used a standard IEEE 118 bus test system. So to start the system, we use a spectral clustering, and based on the eigengaps, we found dividing to the 5 clusters would be the best option for this system. So we divided the IEEE system to 5 areas, as it can be seen here, and there is a quotient graph for simplest showcase in this slide. There are 17 tie lines highlighted in red in this graph, and those red tie lines are the bridges between the 5 clusters here. For the first application, we used Prim's algorithm and found the tree based on the maximum weight spanning tree. It means we tried to keep the lines with the heaviest loading to reduce the shock to the system when we turn the system to the tree partition form. The control islanding suggests that this 5-area network divided by removing all 17 red lines, and it requests a 366 megawatt total power interruption happened, and as a result it required 155 megawatt load shedding needed to balance the resulting. So we tested first to see what will be happen if we use controlled islanding. And then we moved forward with the Prim's algorithm and identified the tree partition network. Tree partition network required just removing 13 tie lines, so less tie lines removed than the controlled islanding. Just 146 megawatt total power flow interruption, and no load shedding showed that required in this system. As you can see in the right down graph, quotient graph, we have a partition network. We have the tie lines between the smaller areas here, and you can see that the areas are tree partitioned. We have changes in the flows, but no changes happened in the export or import power as shown by green and blue color on the boxes between the areas. For the other option, we used the minimization of congestion and load shedding to divide the network to the tree partition system. So consider that a more realistic situation happens. Tree partitioning does cause congestion on some of the transmission lines, here depicted by the green color. How to select an optimal spanning tree that minimize load shedding in this system? So we've tried to find a way for this one. The naive approach was to calculate overloads, and by removing the different lines in 420 possible spanning trees. So it was based on Kirchhoff matrix tree theorem that shows it cannot be a good option. Please note that a linear DC model based on line outage distribution factor that we are familiar with it doesn't work in this situation because we are removing a number of transmission line. It doesn't work in this situation. While we have plenty of publication claims that they work for multiple line outages, we tested most of the IEEE publication in this field, and no one of them work when you have more than 3 or 4 cascading line failure, and after that the results are not countable. And this is an area that we need to do more research if you are interested in that field. We can use AC model as well, AC load flow model, because it is computationally viable on such a system, and we use it and achieved a different repartition network. And the outcome shows that by this method, we can reduce the overload from 62 megawatt to just 20 megawatt. That shows a better situation in the network. So based on this research, now I move on to some of unanswered questions to give you some direction if you are working in this area for the future. Other than the line outage distribution factor problem, we faced 2 main serious areas for the next stage. The first one is modifying the clustering procedure to take tree partitioning. The main and intrinsic concept in the partitioning available in the literature is to divide the network and disconnect it into separated islands. And this is the first problem that is not a good match with what we provided as tree partitioning. All of the known clustering procedures assume that the cluster will be islanded and all cut set will be removed. But spectral clustering, for example, is Cheeger inequality. It doesn't work. So for tree partitioning, we need to keep one tie line as a bridge. So we need to modify the clustering procedures. If you are working in the graph theory, if you are interested in this area, please work on this one with the mathematicians and try to look around the way how we are able to do the sectionalizing and clustering when we need to keep one tie line connected. And the other one is that can we form a tree partition network but keeping 2 lines connected like the one I showed here? If we can find this tree partition network with 2 lines, then we face with the only weakness of the tree partitioning, which was the N-1 security at time of emergencies. And this is another approach we are working with the Caltech University for the future works in this area. I'll just give you a very quick summary of what we discussed today, and then we'll wait for any question you might have. So controlled islanding that provided over the last 2 decades prevents a spreading of cascading line trips, but it is a drastic action and therefore unlikely to be accepted by the utilities and real-world power system operator. A similar effect of localizing line failure is achieved when the cluster level graph is still connected and form a tree. And it was the reason that we provided and proposed tree partitioning as a less drastic option than controlled islanding. A smaller shock will be happened for the system, less load shedding required, no need for resynchronization, which is a serious problem for operators, more likely to be adopted and accepted by the industry because of these specific characteristics. So we generally think that our approach and this mechanism is a 2-step defense mechanism can be taken first by tree partitioning as a less drastic step that can keep the network safe for the first round of preventive actions, and then if that doesn't work, then we have the control islanding as the last resort action. Thank you very much for your attention. If you are interested in this topic, this idea is now published in IEEE transaction on power system. You can scan the QR code or you can use the provided information here on volume 37, January 2022. This work was done by myself and Professor Janusz Bialek, who is a fellow of IEEE in Blackout, and it was the only reason that we could pass the serious and problematic situation of COVID over that 2 years of problems for all of the world. So it was an outcome of research and day and night working on that period. And if you are interested in this topic, one of the recent magazines of power and energy in May-June 2023 dedicated to the power outage. I know that in India you have challenges on the outage. You face some practical problem on that one. It is an area that you are working. So please consider the published paper on the power outage in this specific special issue. That would be of interest as well. Thank you very much for your time, and I'm here if you have any question in this regard.
Thank you, Professor Wahid, for giving the concept of pre-partitioning for this prevention of cascading line failure. And I mean, you have given some research questions also for the students that will going to be to benefit the students in for their research. I mean, the impact of microgrid is, I mean, going to impact this islanding also. And whatever, I mean, through your slides, we have seen that a lot of concepts of how to prevent the blackouts. We in India also we have certain cases of blackouts, and certainly this is going to help us. The researchers also they can they can use these concepts. They can go through the papers particularly written by you and the journals that you have shown. So it's going to help us a lot. Thank you, Professor Wahid. We will connect in future also. Thank you.
You're most welcome. Thank you very much for inviting me to this session.
Thank you.
Last but not the least, we have with us Dr. Srinath Gopal Rao Annavati as the invited speaker. It is my privilege to introduce Dr. Srinath Gopal Rao Annavati, sir. Dr. Srinath is a highly accomplished professional with extensive expertise in the application of fuzzy logic and neural networks in the aerospace industry. With a rich background in both research and teaching, Dr. Annavati has made significant contributions to various aerospace applications, such as addressing challenges like wing rock, developing altitude controllers for flexible spacecraft, controlling flexible robotic arms, and designing robust autopilot for aircraft and railways. Throughout his career, Dr. Annavati has held positions of academic distinction, serving as an assistant professor and associate professor at the IIT Bombay, and later as a lecturer and senior lecturer at the University of New South Wales, ADFA campus, Canberra. His teaching portfolio covers a wide range of subjects, including flight mechanics, flight control systems, missile guidance, spacecraft dynamics, orbital mechanics, and classical and modern control theory. In addition to his academic pursuit, Dr. Annavati has also exhibited a strong commitment to practical applications, with consulting interests spanning flight dynamics, autopilot design for aircraft and missiles, spacecraft dynamics and control, and active vibration control. His comprehensive knowledge and experience make him a prominent figure in the field of aerospace engineering and a valuable resource for those seeking innovative solutions and expertise in this domain. Now, I request Dr. Annavati, sir, to enlighten the audience with his worthy words. Sir, please.
Thank you very much. You can hear me?
Yes, sir, you're audible.
Fantastic. Thank you very much for giving me a chance to have a word with you people. It's very nice of you to say that, okay, I can have a little bit of whatever that I have earned over the years in terms of the knowledge to be passed on to the younger generation, which is basically what I'm interested in looking at. The introduction has been fantastic. I'm not very sure whether it is really I'm worthy of all that introduction that has been given to me. Today, what I will do is, I'm not going to talk too much in terms of the aerospace application, but I will talk in terms of intelligent systems, and in addition, a little bit in terms of multi-agent systems, because practically everything that we talk about in the world today is in terms of intelligent systems, and everybody looks at multi-agent systems. So I'll just try to give a little bit in terms of intelligent systems and multi-agent systems. So I'll try to share my screen. So can you see my screen?
Yes, sir, it's visible.
Yeah, fantastic. As has been indicated, I am with the University of New South Wales at Canberra, working with Australian Defence Force Academy. And Australian Defence Force Academy is like a defence college, which is an establishment between University of New South Wales and the defence. So most of the undergraduate students that we get are from the defence, but all the masters and the PhD students with whom I work for my research, they're all basically from civilian, any international students. So I do have a lot of Indian students. I have quite a lot of Asian students from Bangladesh, Sri Lanka, and different places. So I'll talk to you today in terms of a little bit in terms of the intelligent and multi-agent systems. So let me start with what is intelligence. So everybody thinks that they are intelligent, which is fantastic, because that's what we are. As human beings, we are very intelligent. And why are we intelligent? Because we have got the thinking capability. And what does this thinking capability do to us? And how do we ensure that we have got this thinking capability and we can use this? So that means even to think, is it a good idea to have some amount of training to be put in for thinking? And which is true, because most of us develop the thinking process by the training that we have undergone, right from the mom's lap to the universities and what all that we see around as well. So everything that is there around is trying to train us so that we'll be able to think. And if we are able to think on the situation based on the circumstances that we have got, then probably we are going to be intelligent, which is basically what we are made up of. So whenever we look at this intelligence and whenever we look at this learning that is associated with the intelligence, we look at it in terms of how to learn, when to learn, and what to learn, which are the three important concepts that go along with the learning. And when we look at these three components that are there in terms of the training, the first one, how to learn, is probably the easiest one, because quite likely that mom will have taught to us how to count, dad will have taught to us how to count the money, how to manage our money that is there with us. The school teachers will have ensured that, okay, they are going to tell us what geography we are trying to look at, what history that we have got, what type of mathematics that tools that we need to learn, what is physics, how do we learn, and other things. So this how to learn is something that can be imparted, because if you know exactly what is that you are trying to do, like if you want to become an engineer or if you want to become a doctor, based on that, then you can start preparing it so that you'll be able to learn. And when to learn, even though you are taught how to learn, it's like these are the things that have been taught to you. When to learn is also something that is very important, because not everything you will be able to learn only through like going to the school, by going to the university, right? There are so many things that you need to learn in different ways as well. And when to learn those different things, say like if you get a chance to talk to other people, you will be able to learn more from them. If you are able to go to a different country, you will be able to explore more from that country so that you'll be able to learn more. So when to learn is also something which is very important when we are trying to look at in terms of the thinking capability. And the last thing is in terms of what to learn. Okay. When you say what to learn, that is something that's, as I talked to you, like if you want to become an engineer, then it's a good idea that, okay, you are going to learn more in terms of mathematics and physics. If you want to become a doctor, then you are quite likely to learn more about biology and human aspects that are associated with that. So out of these ones, this when to learn is something which is basically making us something smart or intelligent. Because if we have the capability to learn based on the situation that we have got and use that to behave ourselves, so that if we can ensure that, okay, we are suited to the environment where we are in, then we become basically intelligent systems. And that's what we want to do in terms of all the agents that we talk about. Whenever we talk about the agents, we talk about aerial vehicles, or we are talking about robots, ground robots, or we are talking about underwater vehicles. It doesn't matter. So when we talk about all these dynamic agents, we want them to be as intelligent as human beings, because human beings can think on the spot and try to react based on the situation that they are in, which is what we want to do for these systems as well. And generally when we do this, because the first thing is how to learn is the easier one, as I said, most of the time how to learn is basically done using the supervised training, which is what a teacher does or a lecturer does. So the lecturer will ensure that, okay, there is a supervised learning in terms of how to use, say like if you are looking at aerospace engineering or aeronautical engineering, how do you use aerodynamics, how do you use structures, how do you use flight mechanics. So that is basically taught in terms of, you know what exactly that is going to be told to you. So that way you will have a supervised training. But there are many instances where the supervised training is not good enough, because as human beings, you can't have a lecturer or a parent or a teacher with you all the time in your life. So you need to learn by yourself, where you start looking at it in terms of unsupervised training. And most of the unsupervised training that we do is basically by what is known as a reinforcement learning. What is reinforcement? So if you do something, okay, if you are doing something which is good, then you say, okay, it's a good way that we'll go and do more of it. So that means you are trying to reinforce that. And if you do something which is wrong, then okay, you are going to be penalized because you have done a mistake. So you are going to lose some money. Say like, let us say that you put some money into the share market. So if you put some money into the share market, quite likely that sometime you may get more money, sometime you may lose based on the stocks that you have chosen. So if you have chosen the stocks which are, say like technology stocks, probably today, quite likely that you may feel that, okay, I may choose more of the technology stocks because that's how I have been able to earn more. So that means you have got a reward for the learning process or the thinking process that you have done. And that reward can be beneficial in improving the training process. So if you have done it for technology, then you can do it for, say, like biomedical stocks or something like that. And as human beings, we keep using this reinforcement learning practically everywhere. If you remember, quite likely that, okay, your parents will have told you that if you go to the school and if you get, say, like 80% mark or 70% mark, probably like I'm going to get you a new shirt, I'm going to get you a new pant, or quite likely I will take you to a circus. So that's basically what a reward is trying to be told, to say that if you do something good, then you are going to be appreciated. At the same time, when we do this reinforcement, we also put in penalties. So the parents will also have told that if you go and talk to somebody, quite likely that, okay, you will not be allowed into the home. Or if you don't do your homework, the teacher will say that you are going to be punished. So we use this unsupervised training to ensure that we'll be able to learn as we go along by giving rewards and penalties. And many times we use a combination, because once again, as human beings, some of it is supervised learning and some of it is unsupervised learning. So most of the systems that we work with, they are basically semi-supervised, because initially we impart some amount of training to them, and then we start looking at them in terms of whether they can learn by looking at the environment, so that it becomes a unsupervised learning. So most of the systems that we come across are in terms of the semi-supervised systems. So whenever we say like they are intelligent, that means they should be able to improve and evolve themselves as the conditions change. Human beings are the most adaptive creatures that are there in the world, because we evolve with the conditions that are there around us, which make us very intelligent. All right. And when the conditions change, basically these conditions change are passed on as information. So when we look at it in terms of the agents, we are not looking at the conditions by themselves directly, but we are looking at the information that comes from these changes in the conditions. And if we can use the information that is coming from these changes in the conditions to improve or evolve, then they simply become the intelligent systems. And to ensure that we learn the changes in the environment that we are there, basically we use sensors. So intelligent systems have got a lot of sensors. As human beings, we have got eyes, we have got our ears, we have got a mind, we have got a skin, we have got the hands. We look at so many ways in which we get the feedback, right? So similarly, we put in a lot of sensors into our agents so that we'll be able to learn the environment. And based on that, we'll be able to say that, okay, now you can do something which is going to, you should be able to do what you are planning to do based on these conditions that are there. And for most of these ones, we simply use the feedback systems because the information from the sensor is used by the brain that is there in the intelligent systems. And that information is passed on to say like what is the action that you need to take up. So everything that we look in the nature are in terms of the feedback systems. All right. And basically we want to put these intelligence into multi-agent systems. And when I say multi-agent, they can be either aerial vehicles, or they can be ground vehicles, or they can be underwater vehicles, all right? Because they are the three sets of multi-agent systems that we generally work with as dynamic systems. And what do we want them to do? Like we want them to go from point to point by themselves. And when they are going from point to point by themselves, when I say point to by point travel, so that point to point is basically like there is a certain task that we want to start with, and I want the task to be finished. That's basically what we say point to point. So it is not really a travel in terms of the physical traveling. So the travel is a task that is there from a starting point, which is like you start with raw materials, and then at the end of the day, you want to get a manufactured unit that is coming out from there. And during that time, there are quite a few problems that are going to come. And based on those problems that are there, based on the location that you have got, you should be able to deliver what you are trying to be asked or what is the task that has to be given to you. All right. And in terms of as a general multi-agent systems itself, we look at them in terms of what is known as coverage and mapping. So if you have got a robot, what is that you want to do? If you are having a human being like a soldier, what is he supposed to do? He's supposed to cover the boundary that is there around us. And if you have got an agent, say like a vacuum cleaner in the home, it is trying to cover your home so that you will be able to ensure that you have got a clean place. Okay. And we also want to, most of these agents, when they do that, we also want them to do the mapping, because if you do the mapping, then they can pass on that information to the next agents. So as human beings, what we do is whenever we go, say like if you are trying to drive past a building, you try to remember that building. Next time if somebody asks you, where is the cafeteria? Then you can say that it is next to a particular mall that is there around that. So that way what we can do is we can pass on that information so that we can create a local map of everything that is happening around us. All right. So many times once we create this map, then we know the map, then we can repetitively go around that place, which is like if you know Noida, then quite likely that okay, you'll be able to go around everywhere in Noida without any problem. Yeah, but if you go to Delhi, quite likely that you will not be able to do the same thing. You need to do a certain amount of exploration. And as you explore, once again, you are going to do a mapping. So we want these robots to be able to manage a known area. We want them to be able to manage unknown areas by doing the exploration and then converting that exploration into a mapping as well. And sometimes we also use these multi-agents for what is known as a repeated coverage. And these multi-agent systems have got quite a lot of advantages, but there are also some challenges or disadvantages associated with them. And when we say like multi-agent systems, it is like group tasks that generally the students do, like group study or when an assignment is given. So like in the class, if somebody gives an assignment, say 3-4 of the students are going to say, okay, we'll do the assignment together. So what we'll do is I will do the first part, you will do the second part, somebody will do the third part, somebody will do the fourth part. So then what happens is instead of one person doing the whole task, now the task can be divided. So that way it can become more efficient, possibly more efficient. At the same time, definitely it is going to become faster because instead of one person doing the whole task, you have got 4 people who are trying to do the task for you. And in addition, what happens is if only one is trying to do the job, if somebody falls sick, then they will not be able to do the job. Whereas if you have got 4 of you in the same team, quite likely that if one of you is probably has got a problem, then the remaining 3 will be able to cover it up so that you will be able to manage the task. So that becomes a major advantage of using the multi-agent systems. But for these multi-agent systems, to ensure that they do the proper task, communication is the most important thing. If the communication is good, then there is no problem, right? And generally, whenever we talk about multi-agent systems, as human beings, when you do a group work, you also know that there are some disadvantages. The first thing that comes up is who is going to do what, right? So that is something that has to be sorted out. Because for the agents, we can tell them that, okay, you go and do this job. And probably for the students, I can tell them that you go and do the task. But many times, as human beings, if you are working together, the first thing that we try to question is, why should I do that? Why somebody is taking an easier task? So whenever you do that, so you have to ensure that the task is suitably divided so that you get the best outcome. All right. This need to decide who does what is something which is very important when we talk about the robots or the agents. Similarly, the communication of information is something which is very, very important. All right. And in addition, if all of you are working together, like if 4 of you are working together, everybody looks at the other one to say that in this assignment, is it exactly going to be 25% for everybody? Somebody has done a little bit more work, or somebody may get a bit more marks. So that means you want to challenge yourself against the other person and try to do whether you can do better or whether you can circumvent that individual and see whether you can get a better mark from that, which is basically what you look at in terms of dynamic obstacles. All right. And whenever we say an obstacle, it is anything that is like a constraint that is put into the system. So it need not be a physical obstacle when we talk about the multi-agent systems. So whenever we talk about the multi-agent systems, we generally look at what is known as a mission planning, which has got 2 important components. First one is what is known as the path planning. The second one is what is known as the task assignment. Path planning basically is something which is very important, which is also associated with the control. It is something like the guidance or the navigation that we have got in a system. So whenever you have looked at the control system, I believe that most of you will have looked at the control systems in terms of at least a basic control systems in your engineering course. There is in the block, the circular block that is there on the left hand side, there is a command. So that command is the one which has to come from the guidance system. All right. And based on that command, the controller is going to work to ensure that you get a desired output. So when the basic control system is start, nobody tries to put emphasis on the command that is there because it is simply assumed that somebody is going to give the command. But who generates that command is something which is very important. So when we talk about this path planning, generation of this guidance is something which is very, very important. And whenever we do this, basically, whenever we talk about a path, we are starting from one point. I want to go to a particular point. So that means I start with these raw materials. I want to end up with a final product. So I want to find out what is the way that I will be able to achieve that. So when I say that I want to achieve that, that's basically where you are looking at it in terms of the planning. And that's what I call as the path. All right. So this generally a starting point and a ending point. Quite likely that the starting point may change. Quite likely the end point may keep on changing, because if you are working with, say, like if you are doing your PhD, if you are working with your supervisor, and if you have got a supervisor like me, then you go and say that I have finished this task. The supervisor will never be happy. So I will say, okay, why don't you do the other thing? So that means I'm going to push my task to a different one. So that means these vary up, the task, that end point that you have got keeps continuously varying till you finish your PhD program. All right. So similar to that, if you are trying to kick a ball from, say, like one end of a soccer field to another end of the soccer field, the easiest path that you have got basically is in terms of a straight line. So if I kick it from here to there, then absolutely I'm going to get the goal. But is that possible? Are there any constructions? Are there any constraints or restrictions that are there in the way, which we call them as the obstacles? When you play soccer, you have got your players on your side, which are also going to be on the way as well. And you also have got the opponents who are also trying to do blocking that you have got, so that you will not be able to reach the goal that you are looking at. So that means you have got known constraints as well as unknown constraints that keep coming into your system. Whenever we have known constraints, and particularly which are static, say like if there is a wall, then you simply call it as a static constraint. And whenever you have got, say, like a opponent who is running around to ensure that he takes the ball from you, so we call such constraints as dynamic constraints. Right, so that's simply a figurative way of trying to indicate that I have got a origin and I have got a goal, but I do have some obstacles on the way, so that I can't really use a straight line, but then I have got a curvy path that I need to take. So in life, nothing is straightforward. So everything that we have got is basically through a very curvy path that we have got, where we have to overcome so many obstacles on the way. All right. So whenever we do this path planning, if you know exactly where you need to go, say like if you start from, say like the Amite University, and if you want to go to your airport, you know exactly where you need to go, right? So that means you start from here, go to the right, go to the left, then say drive for another 2 kilometers, another 1 kilometer here. So that way you know exactly what you want to do when you are going there. But when you are doing that, quite likely that you are going to get an information to say that there is an accident somewhere, or something else has happened in the road, or that particular road is blocked. So that means you should be able to think dynamically and change your direction so that you will be still able to reach the airport in the time that you have got. All right. So whenever there are dynamic changes in the system, so this path planning becomes a challenging task. So a lot of work is happening in terms of this path planning in the dynamic environment. And as a general one, quite likely that a lot of people will know that grid-based algorithms and non-grid-based algorithms are generally the two ways in which people do the path planning. When you say grid-based, so basically you know that, okay, I can go to the right, I can go to the left, I can go to the right, or something like that. And whenever you are looking at, say, like a non-grid based one, you are looking at it in terms of continuous operation. How much more time I have got?
Yes, sir, you can conclude in 2-3 minutes.
Perfect. Okay, all good. Okay. So whenever you have got these problems associated with dynamic obstacles, then you need to replan the path. So that replanning of the path is something which is a very active field of research, particularly when you have got dynamic obstacles. When I say dynamic obstacles, so that means you have got a changing environment. So if you are driving your car, if you see some passenger, like a pedestrian crossing the road, so it's like a dynamic obstacle in front of you, right? Then you need to look at it, how fast he's trying to go, or how slow is somebody is trying to go, and then reactively either you are going to brake faster or you are going to brake slow. So that is where you are looking at it in terms of a reactive path planning, right? And this reactive path planning, as I said, is one of the hot topics of research currently. And generally, whenever we do this, we also need to do what is known as the task assignment. And whenever we do the task assignment, there are generally two ways in which we do the task assignment. And one of them is what is known as the compromise view model, and the second one is the nearest neighbor search model. In the compromise view model, basically you try to compromise to find out which is the easiest task, what somebody can do, and who has got a better capability in doing that task. Whereas in the nearest neighbor search model, particularly which are applied for larger problems, you try to identify a set of tasks that can be done by one individual, try to pass it on, but if that individual is not able to do that, then you can share those tasks so that you'll be able to get the best out of them. So there are some discussions that are there around. I'm sorry, what has happened is because I didn't plan myself very well, so I'm trying to rush through quite a lot of stuff. Okay, so whenever we look at these multi-agent systems, in particular for either ground vehicles or aerial vehicles, we need to ensure that they work together. So whenever we say that they need to work together, they need to have good communication, and they should try to stay in some near environment or neighborhood that is there. And that we generally achieve by what is known as a formation control, and second one is by what is known as a swarm. So when we talk about the formation control, it is like a military system where basically you have got rigid rules. Whereas whenever we talk about a swarming, so it is like a loose behavior. So if most of the human beings are have a very loose relationship. They keep somehow maintaining the context and other things, which is basically what a swarm does. But there are a lot of advantages in using the swarming. So there is a lot of research that's happening in terms of swarm for multi-agent systems. So probably if any of you are interested, then you can have a look at that. If I have got under 2 minutes, I can show you one or two small videos, but if not, probably I'll stop here.
Yeah, sir.
Thank you very much.
Thank you, sir. So we are sorry that we are running out of time because we have.
I'm sorry, I didn't plan myself properly. I could have planned a little bit properly.
Thank you for your nice talk, and there are a number of research scholars also. They were connected, and surely they will get a lot of things out of your presentations. So thank you, sir, very much. We will connect to you later on also in future also. Thank you, sir.
Yeah. Thank you very much.
Thank you, sir. You can log off also. Thank you.
Sure. Okay. Yeah. Thank you. See you. Bye-bye.
Thank you, sir.
ICU MSTAT 2019 and TEDP 2021, sponsored by the DST Government of India. He has also been awarded with SSPS Award of Excellence 2022 by Strategic School of Professional Skills, SK Educational Trust, New Delhi, on 27 November 2022. He has developed many visual inspection systems for various industrial and agricultural applications to improve and monitor the quality and reliability of the products. He has guided more than 10 PhD research scholars and presently guiding 2 PhD research scholars. His research interests include wireless sensor network, digital image processing, medical image processing, fruit quality inspections through computer vision, AI, machine learning and deep learning, MEMS and NEMS based smart sensors and system, etc. We are highly privileged to have you, sir, with us today. Thank you for being with us, sir. Now, as we embark on this exciting journey in the world of power system technology, let's also extend our heartfelt welcome to the brilliant participants who will be presenting their research papers today in this session. Each one of them brings a unique perspective and expertise to the table, contributing to the advancement in the field. Let us all encourage and support them with our enthusiasm and appreciation. Now, with the permission of our session chairs, I would like to start the session. And sir, can I start with the first presenter?
Yeah, please.
Thank you, sir. Thank you.
So how many papers are listed in this session?
Sir, 8. Total 8 papers.
All of them are present?
Yes, sir. I think one is not there. But maybe he or she will be joining soon, sir.
Okay, ma'am.
Okay. So starting up with the first presenter, paper ID 26, Ms. Amita Mane.
Good afternoon, ma'am.
Ma'am, are you there?
Yeah, I'm there. Am I audible?
Yes, you are audible. Can you share your screen?
Yeah, but it's saying host disabled screen sharing.
1 second. Just give me a minute.
Yeah.
And I would like to request all the participants that for your presentation, you will be given 5 to 6 minutes and 1 to 2 minutes for the queries and the question and answer. So kindly stick to your time. Just wait for a second. I have informed they're just checking what is the problem, okay?
Okay, ma'am.
Ma'am, can you try now?
Yeah, well, wait. Yeah, it's sharing now. Yeah, wait.
Okay.
Yeah, it is done.
It's visible, ma'am?
Yes, yes, ma'am, it's visible. You
Okay.
can start your presentation, okay?
Yeah. Good afternoon, one and all. My paper ID is 26 and the title is Dynamic Modeling of PV Battery Nanogrid for both islanded and grid connected power control using unified controller. So, this is the table of content where first I will give the introduction, then proposed system and yeah, control. What are the controllers for the proposed system? Then simulation results, conclusion, and the references. So, first of all, due to the challenges in front of the national grid, like
Excuse me for a minute. Is it possible for you to introduce yourself briefly before starting your paper?
yes, sir, yes,
I mean,
yes.
just few
Yeah.
sentences. Okay.
Yeah. Myself, Amita Mane. I'm from Maharashtra, sir, and working in first year engineering department in Pimpri Chinchwad College of Engineering and Research.
Yeah, please now.
Okay.
You can start.
Thank you, sir. So there are number of challenges in front of the national power grid, like the increased demand, then long distance between the generating station and consumers, due to which there is a losses and less efficiency. Also, there are different environmental conditions and distance between the consumers and generating station is also more. So these are the some challenges in front of national power grid. So we have to restructure the this grid and we have to find another solution. So that another solution is a distributed generation which will produce the power close to its point of a consumption. So under this distributed generation we have a new concept like a nanogrid. So nanogrid is nothing but distance between the nanogrid is nothing but generation of the power will be done at a consumer's place only. So here in this work I have used the one of the renewable energy source, that is the photovoltaic system in for the generation of the energy, and it is and load is shared by that photovoltaic system as well as with the national power grid. So the concept behind this control and power management system is that our hello, am I audible?
Yes, yes, ma'am, continue.
Yeah. So this is the proposed system in which our system here I want to prove ki, our system can be system can handle both changing load condition, changing atmospheric conditions, and it acts accordingly. So these are the controllers which I have used for this system. For photovoltaic PV system we are using the MPPT. This is the DC to DC converter, and this is the controller for the inverter to generate the gate pulses. Okay, so and now I will go towards the simulation result, how our system can balance between the generation and the demand. So first results are tested for the grid tied system, that is the on grid system. So first graph shows the power flow management. This blue line shows the grid, black is for the photovoltaic, and two types of load here we are using, DC as well as AC, and red line is for the battery. So first in first case, uh, this is the general operation of PV grid tied system at the 2 second. Okay, PV power is nearly 170. If you observe, it is the 170 kilowatt at maximum power point. This power is shared by DC load, and DC load is 50 kilowatt, and AC load is around 10 kilowatt. Along with the grid power is 110 kilowatt. So load is shared by both PV as well as with the grid. So this graph shows detail of this. Now what happens at 2.5 second? Grid demand falls, and which results in expanding the capacity of battery, means whatever extra generation is there, that will be used for the charging the battery. Then again same things happen at 3.15 second. At this point again grid demand falls and battery adjusts during this adjusts itself this condition. So during this variation effective DC along with AC transports voltage. So our system works effectively during changing load conditions. Second graph shows the AC and DC bus voltage during this operation. Now, in at case number 2, this is also for the grid tied system. In this case our battery is fully charged and state of charge of battery is greater than 90%. So our CAMS, that is the control and power management system, will stop the charging the battery and it will send the additional power to the grid. So whenever demand will be increasing, the energy stored by the battery that will be released to adjust the load demand. So at 3 seconds if we observe, the demand from in grid is increased to 95 kilowatt and AC load is around 22 kilowatt. At that time our AC load is around 22 kilowatt and DC load is around 103 kilowatt. So and our PV is still working at the maximum power point, that is the 170 kilowatt. So battery has controlled this power balance of the 50 kilowatt and it is done by our control and power management system to adjust the load demand. At case 3, in case 3 this is the another circumstance at which the state of charge of batteries arrived at the highest limit. In this case our control and power management system will change the maximum power point mode in the drive set mode. So if at 2 seconds if you observe, PV power falls to near 100 kilowatt. This is the PV power black line and which is falls to 100 kilowatt, and at this condition the battery is having the zero. Battery is at the zero state. So as demand from AC load is 25 kilowatt and DC load is 50 kilowatt, at this condition at 3 seconds again PV goes to maximum power point mode to fulfill the load demand. So this is the another case where our CAMS is working efficiently. This is the voltage of photo PV system and DC voltage for these three different conditions which I explained earlier. Now next case is also for the on-grid system. Here the power flow in the inverter is bidirectional. The inverter which is used, that is the bidirectional. So whenever there is a necessary, the PV battery system can request power from the grid. So there will be a reverse power flow. For the instant when there is available power from the grid, the PV battery system has more demand than the generation. So this control and power management system can reverse the power through inverter to the supply system. So in this case power will be reversed towards the supply system, and in this case the state of charge of the battery is around 10% only in this case, and at 2 seconds our DC load is suddenly increased and DC load is suddenly increased, and because of which causes the DC system request the power from the grid, because we don't have the battery in the charge state. So the PV grid becomes negative at this 3 seconds. It is not a 2 seconds, it is actually 3 seconds. At 3 seconds this DC load is suddenly increased, and at the same time the reverse power flow will start, and hence this is showing the negative power flow. And since there is a not availability of power from the battery bank is not available, so power from the grid increases to balance the system. So here whatever load is increasing, that is balanced by our grid only. So this case study shows the proposed control and power management system rapidly responds this all situation. This is the last grid tied system situation. The inverter has full control of the DC bus voltage as well as on the reactive power also. It is able to provide reactive power to the grid if it is necessary. So here I have shown the reactive power and active power flow diagram. Now when we are going to transit from the grid connection to islanded mode, so at 1.4 seconds if we observe, we have changed our system from grid to islanded mode. So our system take only fraction of second to
ma'am, sorry to interrupt, but you need to like speed up. Okay, just
yeah.
because your time is it's
So
limited.
I will explain, ma'am, in short. Okay. So this is the
And I would request all the other participants to kindly keep their mic off, and whenever they are giving their presentations, keep their camera on. Okay.
So here there is a transition from grid connected to islanded mode, in which our system takes only fraction of second to settle down and to balance all voltages. Here in this islanded mode, now here grid is not available, only PV is available. So battery, this is AC load, DC load, and PV system. So battery and our photovoltaic adjust the both loads, that is the DC and AC load. This is the same condition where load is shared by photovoltaic and battery. And here is the conclusion. So this my system is able to adjust the changing load conditions as well as changing atmospheric condition. Thank you.
Thank you, ma'am. I would request our session chairs to kindly ask the questions, please.
Thank you, madam.
Thank you, sir.
Amita ma'am, can you tell me, your title, what was the title of the paper?
Dynamic modeling of PV battery nanogrid for both islanded and grid connected power control.
Okay, and you were saying that the conventional grid have some disadvantages and you are going to overcome those things with the help of distributed generation, is it?
Yes, sir. Yes, sir.
So you didn't talk about the distributed generation?
Distributed generation, just I'm here using the photovoltaic, so that's why.
And it is a, and one more thing I have observed in your diagrams, the
Yes, sir.
power being generated from the PV source, it is shown as fixed, whereas it's intermittent in nature. I mean,
Yeah, it's intermittent nature. Yeah.
so, and you are showing it a fixed quantity. So, what is
Actually,
the
sir,
reason for that?
actually, sir, this is the one of the objective of my work. So, for before this objectives, in those simulation result, I checked that intermittent nature, and for this objective, I have taken the constant output.
Okay, and you are talking about the PMMT, which you have not described anywhere.
Which, sir?
I mean, peak power. Can you show me your graph, first graph?
Yes.
Yeah, I mean, this one.
This one, yeah.
This one, okay. So, how much is the load demand?
For this case, DC load is 50 kilowatt and AC is 10 kilowatt. We are changing the load condition. Total load is 50 plus 10 kilowatt.
So, your, I mean, the power being generated from the photovoltaic, it is more than the load demand?
Yes, in this case, 110 and 170. Yes, sir. Yes, sir.
Then why are you drawing any power from the grid?
Just a minute. No, sir. This is 50 plus 10, right? So 60, okay. And we are generating 170. So we are feeding to the grid at this condition 110. Along, yeah, we are feeding to the grid.
And what is this grid? I mean, power, where the grid power is going?
Sorry, sir.
Grid power. Are you delivering this grid power to the battery or what? I mean, why this grid power is changing?
That is the load which are connected to the grid. So that is not my concern. I'm only talking about the load which is connected to our photovoltaic. That means this is the nano grid. So I am not considering the load which is connected to the national grid. So that's why this is the extra power which is fed to the grid.
So this P grid means the power which is being supplied to the grid.
Yes. And when it is necessary, it will be come back. Means we can draw the power from grid if it is necessary.
Okay. So grid means nano grid or national grid? Which one you are talking about?
This grid is national grid, and the load is connected to the nano grid.
So how can you this national grid power? You can say that 100 kilowatt.
This power, sir, we are giving to.
No, you see in the graph, this blue color line represent the power grid power, is in?
Yeah, P grid.
And you are saying that it is of 100 kilowatts.
110, yes, sir. At 2 seconds.
How can you rate this grid, national grid of 110 kilowatt?
Sir, we are giving to the grid, na sir. Whatever extra generation is there, after fulfilling our load demand, our load is only 50 and 10, and our PV generated around 170. So this is the 60. So remaining, that is the 170 minus 60, it is 110. That is we have given to the grid.
Okay, so this is the power which is going into the national grid.
Into the national grid. Yeah.
Okay, thank you. Any question from the audience side?
Shall I
Okay,
clear screen?
Yes, ma'am. You can stop sharing.
Thank you.
Thank you, sir. Thank you. I would like to invite my next presenter, paper ID 67.
Ma'am, shall I left if I over?
No, ma'am. You need to stay before the session ends, okay?
Okay, sure. I will mute myself and
Yes.
Yeah, thank you very much.
Okay. Paper ID 67. Dr. Maria Manuel. Yes. Good afternoon, sir. Am I audible to you? Sir, you are on mute.
Yeah, you are audible, ma'am. Please share your screen.
I would request you to please share your screen and start your presentation.
Miss Maria Manuel, please. I think, Ms. Agansa, we can switch to the another paper ID. Meanwhile.
Okay, sir. Okay, so I think the presenter is having some technical issues, so we'll proceed with the next presenter. Sir, are you there? Paper ID 67.
This one, some technical error happened.
Okay, so now is it fine? Are you able to share your screen? Hello.
Mr.
Are you able to share your screen, sir? Sir, I think we should proceed to the next presenter.
Yeah, ma'am, I will be waiting.
By the time, sir, you fix your technical glitch, whatever the technical glitch is there. Paper ID 177.
Yes, ma'am, myself.
Yes. Kindly switch on your camera and start sharing your screen.
So I am sharing my screen. I couldn't able to start my camera because it affects the internet speed.
Okay, start sharing your screen, sir.
Yes, ma'am, I'm doing. Hello?
Yes, sir.
Is my screen visible to you?
Yes, sir, it's coming. 1 second. Yes, sir, we are able to view your screen. Kindly proceed in the screen share, slideshow mode.
Yeah, ma'am, I had done. Is it visible now?
Yes. You can proceed with your presentations.
Okay. Good evening to the session chairs and the organizing committee of RDCAP for accepting my paper to present in this conference. And myself is C.H. Nagasaikalyan. I'm from Department of Tribly, Vasireddy Venkatadri Institute of Technology. My paper is 177 and my paper title, Black Widow Optimization Algorithm Tune, IDDF Controller for Frequency Regulation of Interconnected Power System with HVDC line. So coming to this contents, these are the contents that I would like to deliver in this presentation: introduction, power system under investigation, communication time delays, control and objective function, result analysis, conclusion, and the references. Coming to the main highlights of this work, in this paper, load frequency control, in short I call it as LFC. LFC of two area thermal hydro system with communication time delays is investigated, and the integral double derivative filter controller, that is IDDF controller, is chosen as the secondary controller. So the parameters of IDDF are found optimally using the Black Widow optimization algorithm in this work, and moreover, the efficacy of the IDDF controller has been showcased with the performances of tilt integral derivative TID and a conventional PID controller. Further, the impact of communication time delays on system performance is demonstrated, and moreover, the HVDC line, that is high voltage DC line, is integrated with the interconnected power system model as supplementary controller in order to attain improvement in the system performance. So coming to this a power system model which have been considered for investigation, this is the model. So which has two areas, one is area 1, another one is area 2. Area 1 is integrated with the thermal unit which is having a reheat turbine, and area 2 we have considered a hydro unit, and moreover for that hydel plant I have considered an electric governing system. Okay. So here we have considered the communication time delays here. So let me explain briefly about the communication time delays. So we already know the interconnected power system has been situated in a very large area, which is of very wide extent, and definitely for transmitting and receiving the data from the distant places to the numerous locations. For example, let's say it is a command center to generate an appropriate control signal. Definitely, a communication channels is necessitated. So every interconnected power system operates the communication peripherals, and the communication peripherals is having a tendency, that is, they have the inherent nature of communication time delays. They can transmit and receive the transmit the data from one place to another, but not instantly with a particular time delay. That delay we call it as a communication time delay, and this is the mathematical model of a communication time delay, e power minus s tau d, where tau d is a time delay parameter. By expanding this in a Taylor series form and restricted to the only a first order, the delays have been considered with the interconnected power system to analyze the dynamical behavior of the power system more near to the realistic environment. Why? Because a bulk volume of literature is available in load frequency control, but only a limited attention has been given to the consideration of communication time delays. But in realistic practice, the interconnected power system is facing more issues with these communication time delays, especially in the aspects of stability. So that's why this paper has been given a greater attention to these communication time delays. Coming to this control and objective function, this is the structure of IDDF controller, where Ki represents the integral gain, KDD is a double derivative gain, N is a filter, and these are the parameters which are to be found optimally using an optimization algorithm. Means we need to find the parameters of Ki, KDD, and N, so that the parameters must be best suitable for the planned model. So input is area control error signal, that is the combination of frequency deviations in area 1, area 2, and the tie line power flow. And U of S is a command signal which have been given to the planned model. And the optimization process have been done with respect to the minimization of ITAE index, that is integral time absolute error index. Coming to this optimization algorithm, Black Widow algorithm has been chosen. So the steps involved in the design of Black Widow algorithm is initialization of the parameters and create cannibalism. Cannibalism is nothing but eating of the child spiders by the mother widow, and population renewal, and based on the time domain objective function and when it meets the stopping criteria, definitely the optimal parameters of IDDF controller has been revealed. So this Black Widow algorithm has been coded in MATLAB.m file format for a population of 100, and optimization has been done up to 50 iterations. The detailed mathematical modeling of this algorithm has been given in the paper. So coming to the simulation results, this is the case 1 analysis of the system, that is multi-area thermal traditional thermal hydro system with communication time delays under various controller. So the dynamic behavior of the considered power system has been analyzed for a disturbance in step load of 10% in area 1 under various controls like PID, TID and RDDF in both the areas, and these are the system dynamical responses. If you see the dynamical responses, definitely the responses in red color are very less deviated and also attains the stable position, that is 0 position in peak time. So this we can say that the IDDF controller is sufficient enough in handling the dynamical behavior of the system, that is the stability of the system, especially under disturbance conditions. So IDDF is more superior when compared to TID and PID in terms of settling time as well as the magnitude of the peak deviations, that in terms of undershoots, peak undershoots. And these are the responses settling time, numerical results. Definitely the responses with IDDF are very less, considered very less time. And also the ITAE objective function is very much minimized with this IDDF controller optimized with Black Widow optimization algorithm. And these are the controller gains which have been obtained using the Black Widow optimization algorithm. Coming to the case 2. Earlier case, the responses of the system considering the communication time delays with the time delay of 0.25 seconds. And here in this case 2, analysis of the system performance with and without the communication time delays. So from the earlier case, it is very much clear that IDDF is more efficient when compared to the others. And here we would like to reveal the impact of the CTDs under the IDDF controller. If you see, the responses under black color are more deviated when compared to that of responses in blue color. The responses in black indicates system responses by considering the communication time delays. With considering the communication time delays, definitely the responses are more deviated in terms of peak undershoots, and the time considered by the responses in reaching the 0 state position is also more when compared to that of the system responses avoiding the CTD's consideration. So as because with the communication time delays, definitely there will be a delay in the command signal given by the controller to the generation units in altering the power generation, that is in varying the power system operating point. So with this delay in varying the power system operating point, definitely the real power mismatch might get increases. Real power mismatch is nothing but a difference between demand and the generation in the interconnected power system. So this real power mismatch is having a direct analogy with the frequency deviations. If real power mismatch is high, frequency fluctuations are high. So in order to mitigate these frequency fluctuations, we need to minimize this real power mismatch, and real power mismatch will be minimized by varying the power system operating point based on the command signal given by the controller. With this communication,
sir, sorry to interrupt. You need to conclude because the time limit is
yes, ma'am. Because this is the major findings. That's why I have been concentrating a minute more.
Yes, sir. Yes.
So with this, the delay in giving by the control signal by the controller, definitely this affects the operation of the interconnected power system that we have been shown in the simulation results. And coming to the final case. So as I already said, the interconnected power system has been considered with communication time delays for a realistic analysis. So definitely with considering the communication time delays, the time considered by the responses is more in attaining the stable position. So in order to enhance this situation, definitely the interconnected power system needs a territorial control strategy. In this work, a territorial control strategy of laying a HVDC line with the system. With this, we have attained a considerable improvement in the system performance. Definitely, if you see the responses in red, which indicates the interconnected power system with HVDC tie line. So with employing this HVDC tie line, definitely a considerable enhancement in the system response is reported here. And this bar chart clearly indicates with the HVDC line and IDDF controller, the time considered by the responses to settle down is very less. That has been shown in the purple color. So coming to the conclusion, the load frequency control study is performed on 2 area hydrothermal system, and to get the realistic analysis, communication time delays are considered. And IDDF controller, that is integral double derivative filter based on Black Widow algorithm, is designed as secondary regulator, whose efficacy is already demonstrated with the performances of TID controller and the PID controller. Impact of communication time delays on system performance is revealed and is also justified, and the necessity of considering the communication time delays has also been established in this work. HVDC line is laid with the interconnected power system, and a considerable improvement in the system performance is attained. And these are the references which have been covered while furnishing this work. Thank you.
Thank you, sir. I would request Anwar Siddiqui sir to please. Yes.
Thank you, Mr. Nagasai Kalyan. You have given a very good. I mean, was there any intentional consideration to have one thermal and one hydro plant? Why
Yes.
not? I mean, why not both thermal or both hydro?
Yeah, yes, sir. We can take, but what I thought is the major novelty is the application of the Black Widow algorithm to the interconnected power system stability. For that, I need to select a widely accepted power system model in the literature. So this is the widely accepted power system model in the literature, and moreover, the effect of communication time delays is also being showcased, which is given a less attention to the by the researchers in the literature.
Okay.
So for meeting, okay, yes, yeah,
now,
yes. Sir.
Now, which type of this communication channel you have considered?
Here the entire analysis have been done in the S-plane analysis, sir. Actually, we have considered.
Which are the options to be used as a communication channel?
For communication channels, we consider it is a Profibus. For that Profibus, there will be a communication time delay of 0.25 seconds that we have modeled in the e power of minus s tau d form as a transport type delay.
Okay, Profibus is a protocol, but what about the media? I mean, which communication channel you have used? What was the media of this communication channel? Was it over the transmission line, or was you using it wirelessly, or which kind of communication channel you were talking about?
Is a Profibus communication channel we have used, sir.
So Profibus, okay. I mean, actually, the media. I mean, you have not mentioned, and since you are saying
it's a wired, sir. It is not a wireless. It's a wired, sir.
Wired, copper wired, right?
Yes, yes, sir. It's a wired, sir. It's not a wireless.
Okay, and you are saying that this communication time delay was of the order of 0.25 second. Is it?
Pardon, sir. Pardon, sir.
What was the the magnitude of the communication time delay? The order was
0.25 seconds, sir, which is a realistic delay. After communicating with the chief engineer in Narla Tatara Thermal Power System, which is situated in Andhra Pradesh, we taken that 0.25 as a realistic time delay.
It may be a realistic time delay, but 0.25 second will be a very long duration as far as the power system, because any mismatch between the generation and demand will lead to the change in the kinetic energy of the system.
Yes,
and that
sir.
will be transferred into the frequency fluctuation.
Yes,
so,
sir.
Within 1 or 2 cycles only, the frequency will be diverted. So
yes, sir.
For me, this 0.25 second is a very long duration.
Yes, sir. But very frequently we can't change the operating point of a power system. Why? Because for thermal and for hydro, we have some realistic constraints like generation rate constraint and governor deadband. Those are such limitations. And
Okay, I do agree.
Here, fluctuations in the
agree.
load demand will be met by the kinetic energy stored in the rotating parts of a machine. That is sufficient enough.
Okay, because you are handling the massive machines, so moment of inertia is also very large.
Yes, yes.
And one more thing, I mean, this IDDF integrated double derivative filter, through this you were able to reduce this communication time delay, or you were able to mitigate it? What was the?
No, this IDDF controller couldn't able to mitigate the time delay, but couldn't able to enhance the dynamical behavior of an interconnected power system to a greater extent.
So in a way, it is removing the harmful effect of this time delay, isn't it?
Yes, yes, sir. It decreases the settling time, means the frequency will quickly attains the 50 Hz frequency.
Okay, that time portion. And what about if there is some, the data itself, the control command which you are sending over the communication channel, and if suppose there are some noises, it got corrupted, then have you considered those aspects also?
No, sir. The data correction that we have not considered, that we will consider in the future scope as the cyber attacks.
Okay, because in SCADA we consider these two parameters, the time delay as well as the security of the data. Because control command is very important data, and if suppose something is corrupted, then you will have the hazard. Anyway,
Yes,
good topic and good presentation.
Thank you, sir.
So it's over from my side. Any
Thank
question
you,
from
sir.
the audience? Otherwise, we can invite the next group.
Yes, sir. Okay. Thank you, sir. Thank you. Okay, let's proceed with the next presenter. Paper ID 290. 290.
Yes, ma'am. I am presenting.
Okay, ma'am. Share your screen. You can start sharing your screen. And if possible, turn on your camera. And I would like to request you to kindly stick to your time. Okay, so maximum time limit is 6 minutes and 2 minutes for your question and answers. So I would request you to stick to your time.
Okay.
Okay, start your presentation.
Are my slides are visible to you, ma'am?
Yes, ma'am, it's visible.
Okay. Good afternoon to all of you. Myself Amulya Goyal. I am from University of Engineering and Management. I am pursuing MTech now. Today I am here to present a paper on assessment of voltage stability using GVSM and critical voltage. These are some contents of my slides. First of all, I will give the brief introduction about my topic. Then I will explain the research objective, the technology which I have used to assess the stability of the system by using GVSM. Then I will explain the algorithm which I have used to compute the GVSM. After that, simulation result, and finally I will conclude with references. Now let us start with the introduction. Due to growing electricity demand in the power system, which has become complex, it can be influenced by many factors, including its operating condition, network topology, and types of disturbances it experiences. These factors can lead to different forms of instability in the system, which must be classified to be effectively analyzed and addressed by the power system engineers. However, due to increased use of technologies as well as the growing interconnections of power systems, has given rise to other types of instabilities that is of greater concern. At the risk of voltage collapse, transmission networks are under stress. So, for the power system to operate successfully, power reliability is important. So, nowadays, voltage stability is becoming a major concern while designing a power network. In recent years, deregulation of the power system has ignited competitive business environment among various generating and distributive companies. So, to ensure a reliable operation, it should be important to monitor the voltage stability of the network. Voltage stability is basically the stability which refers to the ability of the system to maintain constant voltages at all the buses in the system after being subjected to a disturbance from a given initial operating condition. There are different types of voltage stability. Mainly there are two types of voltage stability: large disturbance voltage stability and small disturbance voltage stability. These are further classified into short term and long term. Prevention. We can prevent our system from becoming unstable by using adequate stability margin should be ensured by proper selection of compensation schemes in terms of their size, ratings and locations, or we can control network voltages and generator reactive output, and load shedding is also a good way to prevent our system to become unstable. It can decrease the load demand to balance the supplied power, and operator roles is also the main consideration for the prevention of voltage instability. Operator must be able to recognize the voltage stability related symptoms and take required remedial actions to prevent voltage collapse. These are some research objectives of my paper. First of all, I will present the mathematical framework of GVSM, and I will calculate GVS. I have done this technology on different types of bus system. I have uses IEEE 14 bus system and 30 bus system to test the efficacy of this system. In this study, I have voltage stability is monitored by using the critical voltage and global voltage stability margin. GVSM is basically used to denote the health of the system. It is utilized as a metric to examine how near the current system is to voltage collapse. Thus, it is serving as an indication of overall health of the power system networks. So, this paper basically presents the assessment of voltage stability using a pi equivalent model by calculating GVSM and critical voltages. This equivalent to bus network I have used to monitor the stability of the voltages. First, these are shunt admittance are connected in parallel. This is a pi network model which I have used to monitor the stability. Basically, our GVSM is denoted by Jacobian matrix, that is 1 by B square 2AVR cos del plus alpha minus BR. Here I have used some ABCD line transmission parameters which establish the voltage current relationship for the transmission line pi equivalent to bus network. This del J, this is the determinant of the Jacobian matrix, is used to denote is used to calculate the GVSM, and the I have also calculated the critical point of voltage stability, which is denoted by BCR, or we can say CVI, that is known as critical voltage index. It is denoted by 1 by 2 A cos del plus alpha. This is my algorithm which I've used. This is the process which I used for computation of GVSM and critical voltages. First of all, execute the base located the bus which is weakest and specify the load power factor. After that, to modify the reactive load while maintaining a steady power factor and gradually increase the active load. Then execute the specified multibus system algorithm. If does not converge, then move to step 9. Move to step 9. Determine the system overall losses of generation, loads and transmission line. Calculate series and shunt losses. After that, to calculate the equivalent impedance and admittance. Then calculate the ABCD parameters. And after that, we will compute through this. We can compute our MAM, VCR and GVSM. If the system do not converge, then again move to step 2. First, again increase the active and reactive power. If it is converged, then we can stop our simulations. These are some simulation results which I have got after simulating. I have used first of all I have used two types of bus system: IEEE 14 test bus system, which consists of 5 generators and 9 load buses. I have tested this technology on first of all on IEEE 14 bus system. From here I have got the results. This is the results for GVSM, and this is the results for IEEE 14 bus system critical voltages. We can see in GVSM, as we are increasing the operating load of the system, GVSM value is decreasing, and in critical voltage, as I am increasing the operating load of the system, our critical voltages are increasing. So from this and in 30 bus system I have also tested this technology. I have got the same result. In GVSM I have got I have observed that as I am increasing the operating load of the system, the value of GVSM is decreasing, and as I am increasing the value of the system operating load in case of critical voltage, these are increasing. So from here I have got that as the operational load rise, it can be seen that the GVSM values fall, which might cause the power system to become unstable. The impact of local voltage breakdown on the overall situation is shown by the GVSM value, which keep dropping or decreasing until the point of voltage collapse is achieved. As well, the GVSM profile provides a reliable indication for the stability of voltage for the study of voltage stability. And again, I have also tested it for critical voltage profile for the pi equivalent network. As the system operating, I have observed that as the system operating load is increases, the critical voltages VCR also rises. That indicate a more critical operating state. Ultimately, at higher loads, voltage collapse occur. So from here, I can conclude that as I am increasing the load of the system, my critical voltages are increases. It means the system is going towards the unstable condition. From here, I can assess the stability of the system, how far my system is from the unstable condition. So I can protect my system to become unstable. I can use some stability margins of 5 devices to control to prevent from voltage instability condition. This technology is basically used to assess the stability of the system. These are my references which I have used in my papers. So, thank you.
Thank you for the presentation. I request to the session chair, they have any queries, so please they may ask.
Yeah, Ms. Amulya, go ahead.
Yes, sir.
This voltage, you know, why does the voltage fluctuate? What is the cause of the voltage fluctuation?
So, due to increase in load demand or imbalance between load supply and load demand, we can say.
No, not like this. The voltage fluctuate because of the mismatch between the reactive power being generated and
yes, sir. Excessive active
consumed.
and reactive power loading can also result in stressed power system.
So basically, the voltage constancy means you have to manage the reactive power, is it?
Yes, sir.
And you are defining a term global voltage stability margin. So
yes,
how do you define this term GVSM? What does it mean?
So it is basically used to assess the health of the system. It tells us about the system, how it is far from the unstable condition.
No, unstable means voltage unstable system. Stability may be of different types. Here we are talking about the voltage.
Yeah, I know.
Is it?
GVSM is not a type of stability. It is a margin basically.
So
which is used
margin between what?
It is used to show it is used to show at different loading condition. As I am increasing my load, my GVSM value is decreasing.
No, that is decreasing. What is GVSM? That's what I want to know.
So it is a metric which is used to examine how near the system is to voltage collects. It is an
System,
indication of overall health of the power system network.
the actual voltage and the critical voltage. What do you mean by the critical voltage?
Critical voltage means critical voltage tells me about the voltages at which my system can be at unstable condition.
No, see the voltage instability means that you are not able to control the voltage at all buses. Okay?
Yes, sir.
It is below the desired value. So for that you have to give the some reactive power support so that you can keep it constant. Because normal operation
Sir,
means the constant.
yeah, I know,
constant frequency.
but I have also work on that. I have used FVSI and LMN index also, but at that time I have written the paper. I have not done that work. I have completed that work now. I have used some margins also, LMN and FVSI index.
Okay, so okay, from I was thinking that you are going to define these terms and actually how you are controlling
Because
this
when
reaction.
I have written that paper, I have only assessed the stability of voltage. I have not used the margins. I have done with margins now. That's why I am not a mention in this, because my paper consists of only assessment only.
Okay, thank you very much.
Miss Anulia, good. So do we have the next paper ID 437? Paper ID 437.
Yes.
So you can share the screen and please don't forget to turn on your camera.
I think you cannot start screening while
Sir, I
the
search the paper ID 67. Hello?
Yeah.
Dear Professor, shall I start the paper ID 67? Performance evaluation of load balance and storage services offering.
You don't mind?
Maybe after this paper, 436.
Okay.
Yes.
Right, paper ID 67.
After 437, sir, you can proceed with 67. Okay.
Okay.
Paper ID 437. You may please share the screen.
Okay. Is my screen visible?
Yeah, visible. You can take it in slide so more.
Oh, I put in slides now. Hello, now my screen is visible.
Yeah, it's visible. Kindly introduce yourself briefly and start your presentation.
Okay. Hi all. Hi to the committee. Myself Abhishek K. I am from Amrita Viswavidyapidam, Coimbatore, from Tamil Nadu. My paper title is Development of Deviation Settlement Mechanism Based Availability Based Tariff Smart Meter. My table of content is I give a brief introduction to my DSM my meter, and I move on to the deviation settlement mechanism, data flow between my modules, market clearing price, and hardware setup, results, conclusion, and reference. Let's see from introduction. In early 2000s, the Indian power grid do not have any discipline and control over the supply and declaration. So we have to control that by creating a regulations. So that first regulation created at Electricity Act 2003, that is called Unscheduled Interchange Regulation. After some years, it was a huge challenge to monitor the source of extra energy drawn by an entity or an extra energy injected by the generator. So to solve this problem, the new the new mechanism to settle the deviation is introduced. That is deviation settlement mechanism. This is used to measure and control the deviation to have the control over money transaction between the entities. So the availability based tariff meter, that is a ABT meter, is applicable for both the seller and buyer, which is based on a new regulation. Our new regulation given by Central Electricity Regulatory Commission, that is called deviation settlement mechanism. So let us see the deviation settlement mechanism. After some drawbacks of unscheduled interchange method which was followed from 2003 Electricity Act from 2003 to 2021. In 2022, there is a new regulation introduced by CERC that is called deviation settlement mechanism. This mechanism give a good picture to maintain grid reliability, stability, and security. This is a pricing mechanism for deviation from schedule. The penalties are not only the penalty put on the generator or the demand side. It not only based on the frequency. It also focuses on the how much deviation. That means the deviation percentage. This method divides the frequency into ranges. So based on that, the penalty conditions are different. It was given by Central Electricity Regulatory Commission. So this is a data flow between this is the data flow between the modules. This is the model what we made. I consider there are 4 entities. I consider 2 sellers, S1 and S2 are the sellers, B1 and B2 are the buyers. So I consider seller 1 as thermal power station. I consider seller 2 as solar power station. Next, I consider buyer 1 as renewable energy rich state buyer and buyer 2 as general buyer. So in seller 1, I have a hardware module of 1 current transformer and 1 potential transformer for measuring the energy and power. This is connected through ESP32, and the seller 2 have same hardware setup, and buyer 1 and buyer 2, these S1, S2, B1, B2 all have the same hardware setup. Next, we need some parameters to calculate their metering values. So for that, first we need the important parameter is frequency. We took frequency from SRLDC live website. In SRLDC live website, there is a frequency, grid frequency updating in every second. So we fix that frequency by using some ESP32 background algorithm to fix that frequency. So the first parameter is frequency. The second parameter what we need is energy and power calculation. That is done by CTPT and is placed in S1, S2, B1 and B2. So the calculations done in ESP32 are actual power, penalty, cost for deviation and total cost. These are the 4 important parameters we calculated for all the 4 entities S1, S2, B1 and B2. These all parameters we are stored in cloud. That cloud is called ThinkSpeak, and these all parameters is also displayed in the app Blink up through wireless communication. Next, we do some market clearing price. I already told that there are 2 sellers. For our consideration, there are 2 sellers and 2 buyers. The generating companies S1 and S2 submit their bids to supply amount of electricity in megawatt. Similarly, the consumer side offers B1 and B2 offers some specific quantity megawatt and price. So the buyers and sellers provide their offers and bids. So by using that, we draw some supply curve and demand curve. So the curves are plotted. The intersecting of the supply and demand curve represent the market equilibrium. So that point is considered as the market clearing price. At that point, it satisfies the demand. The supply satisfies the demand. Okay. Next, this is the values we took. The S1 is a seller and S2 the S represents are the sellers. Their bids in quantity. The x-axis is a quantity in megawatt hour, and the y-axis is a price in price per megawatt hour. So these are we plot some graph for the blue line is the graph for seller and red line is the graph for the demand curve. So the meeting point is the market clearing price on that interval. So this is the hardware setup of deviation settlement mechanism. So I already told that I took seller 1 S1 and S2 as sellers, B1 and B2 are buyers. So here the setup S1 consists of CT, PT and ESP module, and seller 2 consists of the same CTPT. On the center there is a ESP for frequency fetching from the SRLDC website, and the market clearing price calculation there is another ESP. Next, the buyer 1 and buyer 2, we also have a bulb load for calculating their own consumption. So this is the hardware setup for our project. So the results what we obtained from the hardware is the results are obtained from S1, S2, B1 and B2 entities are monitored in Arduino IDE platform, ThinkSpeed Cloud, and Blink application. Totally, there are 8 parameters which are monitored in serial monitor of Arduino, ThinkSpeed, and Blink application. For here some thermal power station cloud is taken for analysis. This is the result. I already told that there are 8 parameters which I was monitored through the app cloud, and the first parameter is voltage, and the second parameter is current. The third parameter is scheduled power. The fourth parameter is actual power. The scheduled power is 120 and the actual power is 130. The generation company over injects 10 megawatt. For that over inject, they make the grid frequency goes 52 above frequencies. So we have to put some penalty for that. For that, it makes this values makes the frequency of 50.0. Penalty amount for that time is 6 rupees. So the total cost he get is 786 rupees. So I concluded that the ABT based on DSM proposed by CERC helps to control the grid by monitoring the deviation, thereby maintaining the frequency. In this paper, market clearing price, voltage, current, actual power, frequency, penalty, and total cost are calculating using CT, PT, and ESP32. So to monitor the real-time operation of the system, we displayed that parameters into Blink app and Arduino IDE and ThinkSpeak platform. So for future scope, we also stored that the data in the cloud, take that data, and for future analysis we use that. So thank you.
Okay, thank you, Mr. Abhishek K. If they have any query, so they may ask.
Hello, thank you, Mr. Abhishek.
Thank you.
Yeah. Okay, so you are talking about the 8 parameters which you are monitoring, voltage, current, the scheduled power, and the actual power. So suppose the cell, there are 2 seller and 2, two generator and 2 load, isn't it?
Okay.
Demand center. So suppose the seller has some surplus power.
Okay.
He's asked to produce a certain amount of power. The power available with him is more than that.
Okay.
So obviously, it will result into the frequency fluctuation.
Yeah.
So what is the options available to him now? What he will do about this extra power which is being available with him?
Okay. There is a mechanism in that they schedule their power one day before at night 12 o'clock, so that they only attested that we give that power. So if they unable to do that, they will penalize. There is no way to excuse that. If there is a sudden cut in their generation, there are divided one day is divided into 96 blocks, 15 minutes there they give their schedules. If there is any problem in that, they said if my generation station is some problem. So
the one day before whatever schedule is given, now they are deviating from that schedule because of some abnormal situation. Either there is some fault or there is some tripping of the communication or this transmission line. So they are not able to evacuate the bulk power which is available with them. In that scenario, what they will do? Yeah.
That only I told. They are scheduling by using some Excel sheet. In that Excel sheet, they divided one day into 96 blocks. 15 minutes as one block. If they have any problem, they only told if there afternoon 2 o'clock is any problem, means they inform them to state load dispatch center. They put penalize for only 3 blocks. After that, they give that demand to another companies. For only 3 blocks they get penalized. After that, they changes their blocks to another supporting generating companies.
And what will be the role of this independent power operator there, IPO?
What's an independent power operator?
Yeah. When you are operating the power system as a market, it is ultimately authority is available with IPO. And if the this I mean the S1, S2, and D1 and D2, if they are taking the decision, then what way the IPO will interfere?
No. They are not take decision. Here you see that center there is a frequency and MCP that is considered as state load dispatch center. They inform to state load dispatch center. They will take the decide. These S1, S2, D1 and D2 have not authority to change anything. Just for consideration, there are more sellers and buyers. For our hardware setup, we need S1, S2, and B1, B2. Center there is a frequency and MCP. This will decided by the straight load dispatch center. They only have the deciding factor.
Yeah. Okay. Thank you very much.
Thank you, sir.
Now we can take the paper ID 67.
Yes, sir.
You can share the presentation. And please restrict it by one time.
Yeah.
So we have already running behind the schedule.
Very good afternoon to one and all. This is Dr. Marie Emmanuel Jani, Department of CSE. So my paper title is Performance Evaluation of Load Balancer in Service Level Offering Applications. Here, what you are using the title, that is a service. We are providing the service offering application. So the introductions about is the cloud computing is a worldview appropriately character for IT contributions. So where data and resources are aggregated by the web-based cloud administration organization. So then only we are using the planned hardware and packages for the web people at a reasonable cost. So the sharing the resources can cause a problem with the accessibility of those resources. So we will lead to the crash situation. So the strategy of dispersing the network traffic across many servers is known as the load throttling. So the load throttling, this ensures that no server is overloaded. Load regulation, because the builder's user responses by distributing the assignments eventually. So it also makes projects and sites more accessible to the clients. The reason for this is to understand charge regulation. So it has associated structures through the correspondence body. So the regular load balancing agreements rely on entering the information into the device and require complex IT staff to enter, change, and maintain. Only charge partnership and organization with IT spending plans can achieve better result and get. So they are not cloud-based load tuning. So since the cloud-based basic providers mostly do not allow their how to know to own their own material. So fortunately, the load balancer planning can provide team leaders and consistency while only covering a small fraction of the expenses. Since they work with essential equipment, they are also accessible to independent business. So they are also great for optimizing cloud load as they can have cloud control like in other applications. Distributing computing can be infinite and versatile framework in every asset. So all of the framework assets must work together to meet the customer needs. So related work, with the help of the load balancer, we can isolate and distribute responsibilities between at least two servers in the cloud. Here we are using the cloud service, the physical machines and to the virtual machines, right? So the load balancer can convert the services to the virtual machines and the physical machines. So it is suggested in all cases, regardless of whether you want to at least one companion by using a stack balancer and all circumstances. So we can address at least one of the accompanying needs. Administration consistency is guaranteed, high handling traffic and planning approved. So for example, to indistinguishable cloud services, cloud load tuning is the way in which process resources and responsibilities are distributed across at least one server. The dispatching guarantee the most extreme execution with the shortest lead time. So the shortest lead time, what it will be happen, right? So here the diagrammatic representation I have given about the path, how the user can send the resource request. The cloud resource manager can send the mini objective, that is the load balancing. Mini objective is the load balancing that is made by the genetic algorithm. So what it will do, it will transfer the virtual machine allocation then to the physical machine. So here it can manage and control the traffic peaks on a server. So it can control the traffic peaks on a server. So let it using the kind of balancing network demand and short them between the two servers at the displayed. So two servers displayed in here. Cloud service consumers to the load balancer, consumer service A to virtual server A, cloud services A to the virtual service B. Okay, so the cloud services offering with the load balancer. So in this figure, adjusting an interaction that circulates job and assertions, asset in distributing the computing climate with load adjusting. So association can deal with the application or required responsibility by dispensing assets to the PC. Organizations are.
Sir, sorry to interrupt you, but kindly conclude your presentation. We are running short of time. Okay, just
okay, ma'am.
Okay.
Yeah. So it is the load balance adjustment is a basic piece of sky climbing. The cloud foundation needs to stretch comfortably to handle both upstream and downstream traffic. So when a cloud scales, the scales means is typically run numerous virtual servers. What before I said you cloud servers to the virtual servers. There are numerous cloud servers. So this server, the cloud service will give the message to the virtual server. So scales. So the path that distribute the traffic between these apprentices in the battery balancer. So without your load balancer, the virtual servers being scanned may not be able to detect the common traffic in a planned manner. So the performing load tuning that can be dramatically decreased can also be important to achieve green distributed company. So that explanations begin, these are limited power consumption. First point, load tuning can reduce power consumption by limiting the unnecessary liability. These are the following: software defined network, server load balancing, virtualization, load balance as a server. Better performance, maintain website traffic, handle sudden traffic, flexibility. These are the major consistency of the load balancer. Results and discussion about this. Is a load balancer operation in the virtual level. The operation level service as a load balance. These are categories according to the current state of the system into two types. That is static load balancing, and dynamic load balancing. So static load balancing. So it will regard to stack adjusting a heap adjusting approach, static assuming strict the circumstances of the framework. Dynamic load balancing calculation take into the account the current heap of each IT unit, also known as the hub of the static load tuning methods. The result and discussion about it here, the simulation setting load balancing parameters is weight equal to 3. It means S2 server will be selected as 3 times. So 3 times means must be the other servers. Default weight is 1. So start in 30 seconds. Specify the time. So which has down is given to recover the operations. Right. So the what has happened? The movement of virtual machine, the idea is to make a machine as a document or record. How could face the piece of the information to utilize? So by keeping us the postponement, the powerful burden, balance should consider a quickly changing the necessity for figure, memory, gadget design, and so on. So the number of virtual machines, load balancer, weight, hop count, accuracy. So the simulation result of the Amazon Web Service coding Ninja representation. The conclusions about the load balancer of storage level service offering application. It's a cloud computing strategy by which various customers can access the various resources on the web according to their needs. So there are huge barriers to distributing the computing. The load regulation is a major obstacle in distributing computing. The numeric, static, and dynamic calculation are examined in the LOSER. So, however, the dynamic load adjustment calculations are different to show, but they all fit in the different idea of the cloudy condition. The distributing computing adjusts expenses related to head reduction. Further, developing framework, execution framework increase administration time and governance. These are all the relevant. Thank you.
Thank you, sir. I would request our session chairs to please ask for any questions.
Hello, Mr.
Dr. Maria Manuel.
Yeah,
Yes,
Dr.
sir. Yes, Professor.
Yeah, I mean, distributed computing, you want to keep the load balancing among the servers. For that, you are using the virtual machines.
Yes, correct.
Beside the physical one. So it means that the type of load which is being assigned, is it uniform or similar kind of? Suppose the nature of load is not similar. I mean, one requires more. I mean, one is more. This computing require more data processing as compared to the other one. So one will require a longer duration for data processing. Then in that situation, what will you do?
So here that we are using the load balancer services, sir. So the load balance services use load balancing technology to meet the fast traffic application. So that organization developing private cloud infrastructure.
Okay. And in case of dynamic load balancing, I mean, suppose the nature of the load itself is changing then?
Yeah. So it is a unique job when a business to be allocated to the respective status, the dynamic task that is in the dynamic load balancing dynamic stack calculation take into account the current heap of the each IT unit. So that's we have mentioned is the hub.
Okay. Okay. Thank you very much, sir.
Thank you for all those who are sitting in the test. Thank you very much.
Thank you, sir. Thank you.
Thank you.
Next is paper ID 440. Paper ID 440.
Yes, ma'am.
Okay. Yes, ma'am. Kindly share your screen.
Kindly try to give presentation 5 minutes because we have one more paper ID after this.
Kindly introduce yourself and start the presentation.
Ma'am, is my screen visible?
You are not audible.
Ma'am, your voice is not audible.
Okay. A very good afternoon to one and all present here. My paper ID is 440 and
No, there is some issue. We are not able to.
Yes, ma'am, I think there is some technical issue.
Let us start.
With the
take
next,
up the
can
next
we proceed
paper.
with next?
Meanwhile, we'll sort out that.
Paper ID 440. You have in the meeting, so please you may share your presentation. Paper ID 440.
So she's having some technical glitch, I think. So we can proceed with the next paper ID 55.
So may I can share the screen with paper
ID? Yes, yes.
Sir, please try to finish it as fast as you can.
Hello, am I audible now?
Yeah, now you are audible.
But ma'am, you need to wait now. Paper ID 5, after paper ID 5, you can proceed then.
Yeah, because they have started.
Yeah, ma'am. Sure.
Okay, may I start now?
Yes, sir, yes.
Kindly introduce yourself and start.
My name is Dr. Javed. My paper ID is number 5. That is the analysis of variable based isolated microgrid. These are the table of content, introduction. Then we go for the isolating microgrid. Then we start with the modified object method. Then result of the low flow analysis. Then conclusion and references. And let's start with the microgrid. Microgrid basically is a grid we can use connecting with the main grid or by disconnecting with the main grid. When the microgrid are disconnected from the main grid, it's known as working in a isolated mode. So in the isolated mode, basically it consists of various DG energy storage devices that are able to fulfill the load requirement and able to maintain the voltage and frequency across the system. Along with that, it also consists of the battery energy storage system, flywheel, and other storage devices. If we go for the definition, so basically, my grid is a grid where electrical system operates independently of the main grid. It is crucial to maintain the voltage and frequency within the acceptable limit to ensure the reliable operation of connected load and distributed energy sources. Whenever microgrids are connected with the main grid, they are not going to face the issues related to the frequency. But when we are disconnected from the main grid, then we start facing the issue related to the frequency. And to deal with all the frequency related issue, we use a different type of the DG, which known as a loop control DG, the DG with the loop characteristics that we mostly use. Now, how we can control the loop characteristics of all the DGs? And for that, we have to go for the low flow techniques. The low flow technique, which is available, like it gives example of neutral absorption method. This technique, which is available, that will not deal with any frequency variation, because that technique mostly apply on transmission system, which never face any issue. Mostly not facing an issue in a steady state, not facing an issue related to the frequency. But in the microgrid, they mostly face the issue related to the microgrid, related to the frequency. So we have to modify this neutral absorption technique. So in this paper, I have modified the neutral absorption technique to deal with the frequency issues. That is a microgrid which controlled by the RDC controller, microgrid control central. We collect all the data related to the voltage frequency across each and every bus, and then give the command to the loop characteristics generator to control the frequency and the voltage across each and every buses. And for giving the command to making the decision that at what value we have controlled the firing angle of the inverter or the DG to provide the active and real power across the system to maintain a voltage frequency, we require this low flow techniques. The technique which we use in this paper, that is the modified neutral absorption method. This modified neutral absorption method is basically a powerful numerical technique used in low flow analysis of electrical power system, including the traditional grid and microgrid. Its primary purpose is to compute the steady state operating condition of the power system, including voltage magnitude, angle, real and reactive power flow, and the system losses. If we compare the neutral absorption method with the conventional neutral absorption method, is that in this neutral absorption method, I am also going to consider the effect of the frequency as well as the voltage across each and every buses of the system. One more type of DG which we are using here, that's known as the loop based DG. This loop pattern is basically an isolated microgrid or control mechanism that helps to regulate the voltage and frequency within the microgrid when it operates independently of the main utility grid. By incorporating these loop characteristics into DER control, the power generation sources within a microgrid, we can share the load proportionally and ensure the balance between supply and demand. These distributed energy sources respond to change in the voltage and frequency, which help to distribute the power among these based on their capacity and availability. This is a modified neutral absorption technique. In conventional neutral absorption technique, we are considering the mostly three types of buses, slack bus, PV bus, and PQ bus. In the microgrid, there is no any slack bus. We are using the loop control bus here. Our loop control bus are those buses where we installed our DG which respond to the loop characteristics. That means they're going to change their P and Q value according to change in the voltage and frequency across the system.
Hello. Sorry to interrupt you, sir, but it would be very appreciated if you could conclude your presentation soon.
Okay. I am coming directly. Now this is the result for 10 bus system. I am considering a DG across the fiber, and you've seen that the voltage profile across the fibers are going to improve along with the frequency, which is 0.94. If I'm going to increase the number of the loop control DGs, now they can further improve to frequency 0.99, and I have connected DG across this bus number 5, 8, and 9. Let's have the conclusion. In this study, the modified neutral method is employed to address the low flow problem of Icelandic microgrid. The generator bus is formulated as a loop control bus in this method to account for the exclusion of the slack buses in the Icelandic microgrid. The approach has been put to the 10-bus system with the loop cat 6. The accuracy of stochastic procedure is demonstrated by the well-good agreement. By adjusting the value of the loop coefficient, we can improve the over voltage and the frequency of the system. From this result, we also seen that by connecting a suitable number of DG according to the requirement, we can improve our voltage and frequency of an Icelandic microgrid. So this technique may be simply implemented into a partial technology of all the kind, and due to the foundation in the convection neutral technique and ease of the use, it might be a helpful tool for utility employee managing the operation of the grid. So these are the references. So thank you. And question.
Thank you, sir. Thank you. I would request our session chairs to kindly ask if any queries.
Mr. Javed, thank you for your presentation. You are going to replace the slack bus with the droop bus in case of modified Newton-Raphson method, isn't it? The slack bus.
I'm not going to replace. Basically, I'm not going to replace. Basically, slack bus deal with this power balance issues. I'm going to do control buses that deal with the frequency and the voltage related issue when it's not connected with the main grid, like that.
The question is that frequency means that the balance between the active power being available and active power being consumed, isn't it? And voltage means the reactive power balancing. So in the end, you would be required to keep these matching so that the frequency and voltage remain constant. How will you achieve that without any, external support, by simply having this droop controllers?
So we have a DG. Basically, the DG with changing the voltage and frequency across the system. This DG is going to supply the real and reactive power to the system, and by that way, we can able to maintain this voltage and frequency issues.
So, what would be the nature of this DG, which can supply you the reactive and active power?
That may be a diesel generator, maybe any generator which is able to supply both real and reactive power. These are the
that will be able to give you the required reactive power as well?
Yes. With the energy, it may be energy storage devices connected with the energy storage devices sufficient to carry all the load.
Okay, thank you.
Technical things, you can't supply all the load. You have to disconnect some of the load are there. I am considering a small system. In fact, it's not feasible. You have to disconnect some of the load to maintain the balance between the generation and demand.
Okay, thank you very much.
Making a base study.
Thank you.
Thank you, sir. Next is paper ID 440. Paper ID 440.
Once again,
yes, ma'am. Am I audible now?
Yeah, now you are audible. Please.
Yes,
hello?
Yes, ma'am. Yes, ma'am. Please proceed.
Hello.
Proceed.
Am I audible, sir? Yeah. So good afternoon, everyone present here. Paper ID is 440, and I am the. Okay. So the paper title is clearly seen in your screen: order reduction of linear dynamic systems using recursive polarity technique and Pardee approximation. So the table of contents, the flow of the presentation would be like that. Would be the first I'll introduce you what the topic is, and next the problem statement, and later on description of methods. After that examples, and I'll conclude my presentation. So basically, I have introduced a method to reduce the higher orders. I have used two linear systems like single input and single output, and multi input, multi output. These continuous linear systems are to be reduced by using the proposed method, and the numerator polynomial is reduced by using the Pardee approximation. So the problem statement is, as you can see, the GS. GS is the original higher order of basically higher order system of single input and single output system, and we have to reduce it to the kth order. Similarly, the problem statement for the MIMO systems is GS for the nth order, and reduced. We are going to reduce it to the kth order system. So the idea is, first we need to determine the denominator polynomial for the kth order, which approximates the properties or the constraints of the nth order system. So we are taking the denominator, and it contains n number of poles. Suppose there are r number of real poles in it. So we will make a cluster, or we will make an array of those poles, and find out the most dominant pole by using the method. PC is equals to summation I with I from 1 to r under the root of Pi divided by r square, where r is the number of poles, and we have repeated it r plus 1th time. So iterations would be r plus 1th time. So if we are getting not the real poles but the complex conjugate poles, again the method is applied separately for the real part of the conjugate and the imaginary part of the conjugate separately, and we will find out the clusters. So finally, we will get, after getting the cluster centers, we will make our denominator in such a way S minus PC1. Suppose 3 clusters, suppose k number of clusters we are getting, we are reducing our system into the kth order. So k number of cluster centers we are getting. So our denominator polynomial would be S minus PC1, and similarly, and so on. And next, we have reduced our higher order denominator to the kth order denominator. The next part is, we will determine the numerator of kth order using the Pardee approximation. This is already in the literature. This method is already in the literature. I have used that. For the nth order, the power series is obtained in such a way that we will use this equation number 8. And in case of the MIMO, we will separately find the numerators of the transfer matrix into the kth order.
I'm sorry to interrupt. Kindly, please conclude your presentation. We are running short of time.
Yeah, sure, ma'am. So so I would like to conclude my presentation with an example. I have taken the transfer function of 4th order, higher order, and I have reduced it into the 2nd order system, that is 3.4477. And to show you the errors, or to show you the comparison between the proposed model and the reduced models previously done. As you can see, the IAC, the minimization of the IAC clearly shows you that it is approximately this G2S is perfectly matching, is approximately matching with the original system, with the having the minimum number of errors in it. So for the response I have for matching, for the comparison of betterment of our this method, I have shown you, I have given the reference for the step response in the Bode plot. As you can see, the system in the orange line is the in the blue line, which is not clearly shown here, because my reduced system is perfectly overlapping with the original system, and I have compared it with the previously done methods. Similarly, I have taken here the 4 examples, being the other like complex. I have shared here. I have taken the complex conjugate poles and made out one cluster out of this, and this is of the 4th order system. MIMO, I have considered the 6th order system. The responses are like this. So I would like to conclude on this note that for the dynamic CISO and MIMO systems, I have used the method which is perfectly matching with the higher order system, and the stability. This minimization of the errors clearly defines the stability of the system in the reduced model. Thank you.
Thank you, ma'am. Any questions, sir?
Yeah, just one question.
Yes.
This order reduction will always lead to some errors because you are then getting the approximate model, isn't it? So
Yes,
you are
sir.
saying that you are able to control that error.
Yes, sir.
So yes, yeah.
Yes, sir. You continue, please.
Okay. So I mean, CISO and MIMO, to which one you are better off if you are going for this method of order reduction? Is it
Sir,
more
the
suitable
results
for
are clearly, the results are clearly better in the CISO system. As you can see, the graph here is perfectly matching with the original one. My proposed method is in red one, the red below the this orange line, and the original system of fourth order was approximating. Matlab we want our system. We actually, the idea behind lowering the orders of the system is we want our hardware complexity to be lesser, and so
not only hardware complexity, but your computational efforts also you want to reduce.
Computational efforts are also must be lesser also. So as you can see, here it is perfectly matching, and the error. You can see it is approximately matching. That it is not perfectly matching. It is approximately matching.
It has to be approximately
definitely
only,
it is
no?
going to be,
Yeah. Okay.
yeah,
Okay.
definitely it is going to be the future work.
Okay. Thank you very much. Okay, ma'am. Thank you.
Okay.
Thank you so much, sir. With this, we are here to the end of the session.
What about the paper number 439?
Yes, sir. That has been, I think, shifted to another session due to the time constraint.
You may conclude the session, please, now.
Yes. Okay. Thank you all for being here and making this session and RDCAPE 2023 a successful event. And thank you, Professor Anwar Siddiqui, sir, and Dr. Ashwini Kumar Dubey for being here.
My pleasure.
And I would like to request, sir, if you would like to say a few words.
No, in this particular session, we had, I think, 6 papers, 7 papers.
7, yes, sir, 7.
And all of them participated with full enthusiasm, and they have given good presentation of their work carried out. So we have evaluated them. So it is just the related evaluation. All the works were good, and they are appreciated for their participation in this conference. I thank you, all of you, and I thank the organizers also for inviting me for this session. And thank you very much. With this,
thank you so much, sir. It's always a pleasure to have you with us. And thank you to all the participants for your presentation, and hope you all have a wonderful day ahead. Thank you. Thank you, everyone. Thank you.
हो गया ठीक है। मोबाइल से मैं मोबाइल से उसका बंद करता हूँ ना ऑडियो, सारा डबल वो करेगा। लीव करना है। Participants and my dear colleagues, good afternoon to everyone present here. I am Atharv Gupta, and it is a great privilege to welcome you all to the 5th International Conference on Recent Developments in Control, Automation and Power Engineering, RDCPAE 2023. Today, we gather here to delve into the intriguing world of technology and innovation, exploring the cutting-edge developments in control, automation, and power engineering. Let us commence our second plenary session with the fifth invited talk, focusing on AI hardware safety and reliability risks to enable the future metaverse, presented by a distinguished scholar, Dr. Cecilia Metra. Dr. Metra is a professor in the Department of Electrical, Electronic, and Information Engineering at the University of Bologna, Italy. Her expertise in this domain promises to enlighten us on a captivating and transformative topic. Before we embark on this enlightening presentation, please allow me to introduce our distinguished session expert for this plenary session. Our esteemed session expert brings a profound wealth of knowledge and an extensive reservoir of experience to our gathering, the remarkable background harmonizing seamlessly with the overarching theme of our session. The theme of this session revolves around the concept of the metaverse, a groundbreaking layer that bridges the gap between the digital and the real worlds. Artificial intelligence emerges as a pivotal force driving the metaverse, promising inclusive accessibility and personalized experiences for all. However, as AI advances, so do concerns about its reliability and safety, particularly in the context of the hardware implementing AI. Today, we shall address these safety and reliability risks within the perspective of the future metaverse. So, without any further delay, let's all warmly welcome our special guest, Dr. Cecilia Metra. Dr. Cecilia Metra is the president of the School of Engineering of the University of Bologna, Italy. She is a full professor at the University of Bologna, where she has worked since 1991, and from which she received the laureate degree in electronic engineering and the PhD in electronic engineering and computer science. In 2002, she was visiting faculty consultant for Intel Corporation. She is part of the Italian National Research Center on High Performance Computing, Big Data and Quantum Computing, and of the Italian Research Project on Security and Rights in the Cyberspace. She is 2022 to 23 IEEE Director, Division 5, and she was the 2019 President of the IEEE Computer Society. She is co-chair of the IEEE Metaverse Project of the IEEE Future Directions, and a member of several IEEE committees, including the IEEE Conferences and the IEEE Award Committees. She was editor-in-chief of the IEEE Transactions on Emerging Topics in Computing and the associate editor-in-chief of the IEEE Transactions on Computers. She contributed to numerous IEEE international conferences and symposia and workshops as general and program chair, technical program committee member, and keynote or invited speaker. She published extensively on international journals and conference proceedings on design for testability, reliable, safe, secure, and resilient circuits and systems, trustworthy AI circuits and systems, fault tolerance, photovoltaic and energy harvesting systems, and emerging technologies. She is an IEEE Fellow, IEEE Computer Society Golden Core member, and a member of the IEEE Honor Society, IEEE HKN. She received 2 Meritorious Service Awards, 8 Certificates of Appreciation, and the Spirit of the Computer Society Award from the IEEE Computer Society. I would now like to invite Professor Dr. Cecilia Metra to share her expertise and insights with us. Please, ma'am.
Thank you very much for your kind introduction, and thanks a lot for the invitation. I'm really glad and honored to deliver this keynote at the 5th International Conference on Recent Development in Control, Automation, and Power Engineering. So I will now share my screen. Okay, 1 second. I think you should be able to see my screen. Okay, so again, thanks a lot for the invitation. I'm sorry that I'm not able to be at your prestigious conference in person, but thanks a lot for allowing me to present online. So we will discuss together, we will start addressing together the safety and reliability risk for the AI that is an enabling technology for the future metaverse. And as we know, the metaverse can be defined as a new layer bridging the gap between the digital and the real world. Today, we already have several tools that, for instance, enable a very accurate digital emulation of the real world, for instance, for product design, or an augmented reality experience, for instance, for education, or natural language interaction with a virtual assistant, for instance, for work support, or the creation of a couple digital twin of real entity, for instance, for predictive maintenance, or to provide financial services using blockchain technology and so on. But the novelty of the metaverse is that the future metaverse should include and connect all these already available capabilities. They are already available, but still separated capabilities into a unified environment consisting of interoperable digital and real world with an inclusive accessibility to all. And the expectation is that the value of the metaverse will reach the $5 trillion by the year 2030. And this value of the metaverse will include use cases from a huge variety of industries working, of course, for instance, in transportation, communication, education and training, of course, but also industry in the medical field, and much more. And the expectations are that, again, by the year 2030, the metaverse will reach, let's say, a mature state. And as we know, AI will be a key technology to enable the future metaverse by providing human interaction with the metaverse, for instance, through natural language or gesture recognition, enabling object detection in images and videos. And also AI will enable a personalized experience in the metaverse based on personal preferences, possible disabilities, and so on. And also AI will enable to preserve security, for instance, by monitoring a user's behavior and detecting unusual activity that may be due to cyber attacks and so on. And so the question obviously arises whether the AI that will be a key technology to enable the future metaverse is, and given the wide application expected for the metaverse, the question that obviously arises is the AI safe and reliable? And we know that by definition, reliability is the ability to guarantee the continuous delivery of the intended so-called REST service for a given amount of time, while safety is the ability to guarantee the absence of catastrophic consequences on environment and users in case of misbehaviors. And today we are talking a lot about the reliability and trustworthiness of AI. We wonder if the data used to train the AI are inclusive and fair. We are concerned about data privacy and governance. We are worried about the explainability of AI and the liability of decisions taken based on the AI, and much more. And of course, I believe that these are major issues that, however, we can somehow contribute to solve as we are those who develop the technology, but these are issues that we cannot solve alone. They mandate regulations at the governmental and legislative legal level. But hoping that these issues will be regulated in the near future, a problem that instead is our responsibility to address and solve is that the hardware implementing the AI is safe and reliable. And this is because we know that the AI safety and reliability strongly depends also on the safety and reliability of the hardware implementing the AI. Safety and reliability with respect to possible faults that could affect the AI, the hardware executing the AI during its operation in the field. And these faults, maybe we will see in a few minutes, for instance, the well-known transient faults, bridging faults, and others. And in addition, we also know that the electronic and so the hardware that is implementing and executing the AI is affected by aging phenomenon. Electronic device age, just like humans. And we will see that by aging, they typically become slower, but by becoming slower, they may also make mistakes. So we need to worry, and in this talk, I would like to address, let's say, the safety and reliability risk for the eye related to the possible occurrence of faults and aging conditions affecting the hardware that is executing the eye. So what are, first of all, these faults? A major concern today is due to the possible transient faults. These are faults that are due to alpha particles that, as we know, are atoms of helium that lost the electrons, that may be due to the radioactive decay of isotopes present within the packages of the electronic devices. Transient faults may also be due to neutrons that may be, for instance, generated due to the collision of galactic cosmic rays and atmosphere atoms, mainly nitrogen and oxygen. And when these energetic particles hit the substrate of our electronic devices, we will assist to a modification of the voltage value associated to the heat circuit node. And particularly, we will assist to the generation of a quick and undesired voltage transition, that is what we model, so a voltage glitch or spike, that is what we model and call a transient fault. And what is the problem? The problem is that if we, for instance, consider, as in this simple example, have an alpha particle hitting a node within a combinational part of a circuit, if the transient fault that is locally generated arises till the latching element that we may have at the end of the path, an incorrect datum may be generated at the output of the latching element, incorrect datum that in this case, if the cause is a transient fault, is called soft error. And soft errors may put at risk the safety and reliability of the eye because these are erroneous bits that we have in our system. And in addition to this possibility, another concern is due to the fact that these transient faults may actually affect the internal nodes of memory elements. And if this is the case, we all agree that it is even more likely that a soft error is generated at the output of the memory element. And these soft errors are very likely also to affect the cells of memories. So memory elements, memory cells, are very likely, if affected by transient fault, to give rise to outputs of errors. And so, again, we could put at risk the reliability and safety of our AI. And what about aging? The major concern is nowadays for scaled down technology is used to the so-called bias temperature instability that can take the form of either the negative bias temperature instability and the positive bias temperature instability, which is nowadays considered the most likely aging phenomenon for currently scaled down technology. And for instance, what happens? NBTI may cause, and similarly for PBTI, they cause an increase in the absolute value of the conduction threshold of transistors, NBTI for PMOS transistors and PBTI for NMOS transistors. So if you assist to an increase in the absolute value of the conduction threshold, for the same other conditions, what happens is that basically the transistor gets lower. And so we have a delay effect at the circuit and system level. So we have a degradation of performance that has been reported can be higher than 20% in 10 years. So as I mentioned before, basically due to aging, also our electronic circuit and system become slower in their operation, in their execution of what we would like them to execute. And due to this, we could have the possible violation of the timing constraints at the circuit level and the possible sampling of incorrect data. So again, due to aging, we could put at risk, we could have incorrect data in our circuit and system, and we could put at risk the safety and reliability of the eye. And we will see in a few minutes specific examples in this sense. And in addition, recently, in a paper co-authored by Professor Rossi, Professor Omani, and Professor Rossi from University of Pisa, Professor Omani, University of Bologna, and Professor Paganielli, University of Padova in Italy, we proved that this aging condition, aging phenomenon may increase also the likelihood that soft errors are generated due to transient faults affecting our circuit nodes. So they make circuits more likely to give rise to soft errors, so putting at risk the reliability and safety of AI due to aging. So let us see some specific examples related to this risk for AI. So for instance, we have found that if aging affects transistors in the data paths of hardware accelerators implementing neural networks, for instance, used for image recognitions, we have verified that the data path propagation delay increases of almost 35% over a considered 5-year operation time, with an increase higher than 20% in the first year of operation. So the result is that we could have the incorrect hardware acceleration operation in the field with consequent unreliable operation, let's say, of the eye. The eye is executed by this hardware accelerator, a risk for the system safety and reliability. This relates to aging. What about soft errors? Already in 2017, in this publication, it was proven that if soft errors affect memory elements of hardware accelerators that implement deep neural networks used again for image recognition, if the memory elements affected by soft errors are those containing the weights of the neural networks, and particularly the exponent of the weight, what may happen is that we could have the possible misclassification of images. And in this paper, it was, as an example, it was claimed that, for instance, on an autonomous vehicle, a truck could be misinterpreted, misclassified as if it were a bird, with, of course, different actions taken at the level of the autonomous vehicle, and so with consequently risk for the system and reliability of this autonomous vehicle. And similarly, we have recently proven that if we consider, for instance, soft errors affecting memory elements of hardware accelerators, in this case, implementing neural networks used to monitor the state of health of batteries that may be adopted, for instance, in safety critical applications, just like biomedical applications. If the memory elements affected by soft errors are those containing the neural network weights, in this case, up to the 70% of degraded batteries can be erroneously recognized as non-degraded, with obvious consequent unreliable operation of the eye and consequent possibly dramatic consequences on the safety and reliability, for instance, of the biomedical system. And this is a research that we conducted together with engineer Sara Creti from University of Bologna and Professor Romagna from University of Bologna and engineer Borelli from company called Beghelli in Italy. And similarly, on a different application of AI that is, of course, however, very relevant, especially in the perspective of the metaverse and the security issues of the metaverse, we have found that if soft errors affect, for instance, memory elements of hardware accelerators implementing autoencoders that, as we may know, are a specific kind of neural networks, used to detect unauthorized messages generated during cyber attacks. If the memory elements, again affected by soft errors, are those containing the autoencoded weights, up to 79% of legal transactions may be erroneously recognized as illegal, thus making such transactions inhibited. So in this case, basically security is preserved, but the problem is that a high percentage of legal transactions are recognized as illegal, and so basically we have no availability. So in this case, we have serious risk due to faults affecting the hardware executing the AI used for security applications. We have risk for the availability of the system, and of course the AI is working in an unreliable way. And this is a research that has been published recently and that is co-authored by Engineer Finelli, that is currently working at NSP, but at the time I was a student at the University of Bologna, Professor Romagna, and myself. So we have seen that soft aging and especially soft errors could put at risk the reliability and safety of the AI that, as mentioned before, is a key enabler to the metaverse. So what can we do? And a typical solution that is adopted to protect memories, since the issues was mainly related to soft errors affecting the memory cells containing the weights of the neural networks that are executing, let's say, implementing AI algorithms. To protect the memory elements with respect to soft errors, a well-known and widely adopted approach is to consist in making use of the so-called error-correcting codes. And these are typically used to protect memories. Here in this figure, we have a schematic representation of the hardware that is needed in order to implement ECC, for instance, into an hardware to protect the memory of an hardware accelerator or microprocessor. And an issue that we address, and this is a research that we performed with the partial support of a grant from Intel Corporation, has been to analyze what will happen if this additional hardware is itself affected by faults. And what we found out is that if you consider, for instance, resistive bridging faults that are faults that may occur during the operation of the hardware in the field, mainly due to electromigration, which is a physical phenomenon that takes place in metal lines when they are interested by high current density and especially in the presence of high temperature. What will happen is that if we have bridging faults affecting the additional hardware that is needed to implement ECC, which are a possible solution to address the issues discussed before, these bridging faults may prevent the correction of incorrect words read from the memory, in addition providing an indication that correction has been achieved. Or they could themselves induce errors into words that were correct and correctly read from the memory, so making correct words become incorrect. Again, with an indication that no error was found in the word read from the cache. So due to faults affecting the additional hardware that can be needed in order to protect memories with respect to soft errors, and so this can be a solution to improve, to deal with the reliability and safety risk that we discussed before, we found that, again, this solution may not be successful if this additional hardware is itself affected by faults. So, of course, this is a problem. We addressed this issue in a paper that is co-authored again by Professor Romagna from University of Bologna from Engineer Manfredi, who is no longer at the University of Bologna, myself, and Engineer Locatelli, Engineer Chevacci, Engineer Petrucci from Intercorporation. So we developed also a possible approach to deal with this issue. But this to give the message that we could have reliability and safety risk of the eye, and consequently also if we think about a widely adopted metaverse, due to soft errors affecting the memory elements that contain the weights of the neural networks that are used to implement AI algorithms. ECC can be a solution, but we need to worry about possible faults that could affect the hardware blocks that are in turn needed in order to implement this solution. And in addition, recent research that we have conducted have shown that anyway, ECC cannot be a solution for any kind of memories. For instance, in this recent publication, we have shown that if bridging faults affect the selectors of resistive memories that, as known, are a kind of memory that are very promising and that could be adopted to perform in-memory computing to speed up even more the execution of AI algorithms by hardware accelerators, we found that a bridging fault affecting a single memory selector can affect the datum written to or read from a large number of cells, where this large can be up to 64, which is a number of errors that definitely exceeds the correction capability of error correcting codes at sustainable cost. So for this specific kind of memories that again are very promising because they can speed up the execution of AI, which is another important aspect if we think about the applications enabled by the metaverse, we need to worry about alternate solutions with respect to ECC. And we also started working on them, and all of this has been recently published in this paper that is authored by Professor Romagna from the University of Bologna, Engineer Bardan, that at the time was a student at the University of Bologna, and myself. So I hope that it has been somehow clear that we have to worry about the safety and reliability of the hardware that is implementing the AI. And for those of you who may have interest in this talk, as kindly stated in the introduction to this talk, excuse me, I'm co-chairing an IEEE initiative on the metaverse that we have within the future direction with future directions of the IEEE. And for those of you who we are addressing safety and reliability issues, but not only these, of course, and for those of you who have interest in this kind of technology, please feel free to get in touch with the activities that we are conducting in this field by going to this link, and you can also register for free. Of course, there is no, you don't even need to be IEEE members. You can register for free and be updated on activities that we are conducting in this field. So to conclude, the metaverse is expected to reach so-called mature state by the year 2030. There is the expectation of huge value of the metaverse in the coming years, and huge applicability or adoption of the metaverse and all its tools, let's say, in a huge variety of application fields. AI is a key enabler, artificial intelligence is a key enabler for the metaverse, and given the expected wide adoption of the metaverse, of course, and given the key role played by AI, we need to worry about the safety and reliability of AI. These are critical issues that are of main concern nowadays, especially, I would say, from the societal and ethical implications of AI. From our point of view, at least from the electronic point of view, I think we need to worry also about the reliability and safety of the hardware that is executing the AI with respect to possible faults and aging conditions. From the point of view of the ethical and societal implication of AI, and consequently of the metaverse, hopefully regulations will be specifically devised at the governmental and legal level. There are also several standards that are under development also within the IEEE in this field, and there are also, as I discussed during this talk, several technological challenges for the AI hardware safety and reliability. I hope, given the fact that there is a lot of research in this field, that the safety and reliability risk for the AI hardware will find a solution in the near future, so that hopefully we will have a safe and reliable metaverse available to all of us to hopefully benefit our lives and impact and environment. That's all. Thank you very much for your attention.
Thank you, Dr. Metra, for sharing your valuable thoughts on the subject. Your expertise is truly valuable to everyone at our conference.
Thank you, Professor Cecilia. It's a wonderful talk on AI-enabled future metaverse. I mean, you have talked a lot about AI, and the future is AI, in fact. But there are a lot of concerns also, like privacy concern is there, and I mean, private data, that is a concern. Then also there are some creativity risk is there for the human being. But since AI is future, and the precision with which AI can do the work, probably human being cannot. So in future, we are going to do a lot of work on AI, and your research in this area is, I mean, a lot of researchers will follow here also. They are connected. I must congratulate you. I must thank you for giving us such a wonderful talk. Thank you, ma'am.
Thank you. My pleasure and honor. Thank you very much for the invitation.
Now, as we proceed further, we are excited to present the sixth invited talk on intelligent monitoring and control of robotic systems by Dr. Rupam Singh, Assistant Professor at the University of Southern Denmark in Denmark. Dr. Singh's presentation promises to delve into the forefront of robotics, exploring advanced methods to enhance efficiency, precision, and autonomy in robotic systems. But before we dive into Dr. Singh's talk, let me introduce our esteemed speaker. Dr. Rupam Singh is an assistant professor in SDU Robotics Department of the Max McKinney-Moller Institute, University of Southern Denmark, Denmark. Previously, she worked as a postdoctoral researcher at the Institute of Smart Systems Technologies, Alpen Idria Universitat, Klagenfurt, from 2021 to 23. Her postdoctoral research was a part of the project Learning to Fly Live, which was funded by the Austrian Science Fund, FWF. In project, she handled the problems of path tracking, speed control, maneuverability, and balancing control using reinforcement learning, which are highly affected by the complexity and unpredictable dynamics of the surroundings. She investigates the research questions in the field of intelligent and fault classification based control of unmanned vehicles. She completed her PhD from DTU, Delhi Technological University, on intelligent control of robotic system in 2021. Her research activities are focused on monitoring and control of diverse robotic systems, such as manipulators, quadrotors, dexterous hand, and robotic balancer. A particular focus of her research is on application of machine learning in control, reinforcement learning, and real-time monitoring of safety-critical systems that range across various robotic systems. She has her expertise in the fields of control theory, machine learning, data-driven analysis, robotics, and reinforcement learning. I would now like to invite Dr. Rupam Singh to share her expertise and insights with us. Please, ma'am.
Thank you for wonderful introduction. I would like to share my screen first.
एक मैसेज आया था ना व्हाट्सएप आया था पहले मुझे व्हाट्सएप किया था उन्होंने
So is it visible now?
Yes, ma'am, it's visible.
Okay, perfect. Okay, so as you already introduced me, but I would like to give a slight introduction also. Um, so as I'm Rupam and working as assistant professor in McMcKinney Mole Institute of Southern Denmark University. And today we'll be talking about intelligent monitoring and control of robotic system. So this SGU, Southern Denmark University, is quite big, and we have like 6 different branches and 6 different places in Denmark. And but the main branch is this Odense University or Odense area. So I'm working with that. And in Odense we have like different institutes also, but like for science, art, political, and so many. But as I'm working with the technical faculty, and in technical faculty, I'm typically talking about robotics area. So in robotics, I'm working with this. We have like so many different groups, and I'm working with this STU robotics. Like we have this US Center for the aerial vehicles, biorobotics, and so many other metaverse for the gaming and all. But I'm working with the STU robotics. So in SG robotics, we are dealing with the mathematical modeling and control of the robotic systems. And when I'm talking about the robotic system, I'm saying about the manipulators. Like we do have mobile robots and some service robots also, but the main research is going on with the manipulators. So we do this mathematical modeling thing, and then we have a group that's working on the computer vision of the robot. So with this computer vision, we'll be having the information about the simultaneous localization of robot in the environment, in the field, and it will actually map the environment, and it feels like as you feel in the same environment. So it will give you the actual view for that. And then we have developed so many simulations, and we have developed our own software for that. And and also it's like we have achieved quite automation, and we have done some automatic industrial tasks, and we have so many collaborations with different UI robotics and so many different industries to perform these certain tasks. Now, as already mentioned earlier, that I have worked with a lot with unmanned aerial vehicles, and my actually postdoc and PhD is all about that. So I'll talk a bit basic about the type of aerial vehicles, and then I'll move forward. So there's you can see from the first picture, there's like multi-rotor drone. So as the name suggests, there's like so many propellers. So the advantage of using this multi-rotor drone is that it has like fluent and like very perfect maneuverability. So it can like tilt and rotate in any direction very fastly, and it has a good speed as well. But the main advantage is its orientation capability. And but the thing is with that, it cannot survive for long period of time. So battery limitation, because you can see that's like very small space for the battery. So it's like very not for it cannot work for the long period of time. And then the next is the fixed wing drone. So from the picture, it looked like an aeroplane, and it has the same phenomena. So it has like the fixed rotor there, and the thing is they have like amazing speed, and they're like more stable. But the problem is the rotation or the orientation. So to take a turn, they have to take like a long path rather than just on that place. So they cannot do this vertical takeoff and landing kind of thing, which could be done by the multi-rotor drone and also by the single rotor drone. And the single rotor drone is the exact replica of the helicopters. We have there like 2 rotors, one for main, one for the trail rotor, and then there's like they are so good with the vertical takeoff and landing. They are so good with the speed also, and they are like stable for sure, but not as stable as with these fixed wing drone. So these are like the typical types of the vehicles. And then I've analyzed the area of or the domain of this UAVs in different form, and the main objective of this is to how you can actually control these kind of things. So I've developed like couple of control techniques, and I've identified the way how you can actually monitor the conditions of this UAV or like aerial vehicles, and then how you can use the different machine learning algorithm in order to get the faults in it. So like if there's any kind of fault is occurring in the system, how can you actually identify it, and then you can detect it, and then you can eliminate it by using some fault tolerant controller, or maybe you can use some reconfigurable controller. Both have like different aspects of solving it, but I mean, this could be like correlated. So then the autonomous learning was also an aspect of controlling these drones. So in autonomous learning is basically you ask your vehicle. It could be like anything. Your aerial vehicle. It could be a normal robot, like anything. So what you do, what this term suggests is like it for the drone, it says, okay, from A point to B point, you have to move, and then you have to figure it out on your own. You will not provide a proper path to it. You will say, okay, these are the coordinates, and you just need to go there. And also, you will not provide the information about the velocity, its orientation, nothing. So it comes with the learning. You use a lot of reinforcement learning for this, and then that's how you learn your path, and that's how your drone become the intelligent drone. So yeah. Then the applications, I mean, right now the application of drones are like quite vast, and everyone is using for the photography for sure, and the videography either in weddings or like in film industries. And other than that, it's like we use it a lot in the military and search and rescue operation, delivery, and also in the agriculture. In agriculture, generally it's used to sprinkle the pesticides on the crops, and so that it reduce the human task and everything are like super fast. So these are like the main applications. Now on typically aerial vehicles I'm talking here. So in typical aerial vehicles I have identified these main research area on which couple of the points are those like on which I have worked, but there's like couple of the points on which I'm planning to work, and some are those that I have not touched yet, but maybe in future I'll do that. So these improving the trajectory, and then the fault tolerant controller, and then the fault detection and localization are those areas where I have already worked and got some publications on that. And then this estimation remaining use of life is all about finding the life of your robot, or finding the life of your remaining useful life of your vehicle. So basically when you deal with this lot of data during your fault detection and localization, because you inject a fault and you get the data, then you have like a lot of information about how this exactly particular thing is working. So in that sense, you will then define different levels, and like based on the risk analysis, based on the risk identification, and you based on that you develop the reliability model on that. So this is like something like really good thing to provide for the industrial perspective actually. And then this simultaneous localization and mapping is all about the computer vision, and coordinating multiple UAV system is something, I mean, you all have heard of this drone shows. So you have seen these drones are swarming around, and they are like having control with each other. They are talking with each other, let's say, and then they have to do some task and do some design, do some fly in a certain way. So all this comes with the coordinating multiple UAV system. So as I said, I've worked with these two systems already, the unmanned aerial vehicle system and the balanced robotic system during my PhD. And in that, I have developed like so many different control techniques, starting from probabilistic control, classical control, intelligent control, and then some optimization algorithm-based meta-heuristic methods also. And when I mean in both the systems, but these systems are like with the limited degree of freedom. So the idea for the unmanned aerial vehicle is to stabilize the yaw angle and the pitch angle so that it will balance properly. And for the balancing robotic system, the idea is to make the ball stay on the plate. Even if you provide any kind of disturbance or something, the ball should not fall on the ground. So that's the idea, or that's the control objective for defining these different controllers. So first of all, I'll talk about probabilistic control approach method. So probabilistic control approach is basically a part of the robust control design, and then here you basically use this cost function, and you want to minimize this cost, and by using some simultaneous or stochastic optimization methods. So there's like one approach is using some randomized algorithm, and in randomized algorithm, what you do, you provide a random matrix or random parameter when you have like so many random variables, and that gets into your input. Now, when it gets into your input, and then it calls like a typical M delta model of the robust controller control theory. So it's like then you develop a new control system with this uncertainty involved in your system already. So there's like good part and bad part about it, is that like the good part is that you will get the solution like very frequently, because it gives the same for the same input, it gives every time a different output. So it's very random in nature, as the name suggests, like because we use the probabilistic design parameter as a design consideration. So because of that, it will be like sometimes it will give you the answer in a one go, and sometimes you have to take like a lot of runs to get the proper optimized gain matrix. So that's how it works, probabilistic control approach. Then I've worked with this meta-heuristic approaches as well. So there's like so many algorithms, PSO, GA, DE, like, where you have like large amount of vast data, and then you have to find a global optima for that kind of system. So in that sense, I have used this ant colony optimization method. So how exactly this thing works? So in this thing, there's like an ant. It starts to follow a path, but when it follows from one place to another place, it leaves a pheromone. A pheromone is something that a liquid that is left by the ant, and based on that, the other ant will get to know about it, and then it sends it, and then it follow the path. So this is how it actually complete its task from reaching from one point to the another point. So this is how they finish the task, and but then at the same time they all are going together. So when it goes for one time, then it's like might have like longest path, but then they are coming back, then they might figure it out the second part, and in certain way they'll find the global optima or like the optimized solution for that. So then the intelligent control, I have worked a lot of intelligent control methods. In intelligent control methods, I have developed a fuzzy logic controller, and then a combination of these fuzzies with different thing like neural with the neural with the I have developed this evolving type 2 quantum neural fuzzy neural network also, where there's like the rule is automatically updated based on the growing scenario. So you don't actually provide the proper rule base there, but then you said, okay, these are like the certain rule, but you have to update as per the input. So this is how this the quantum fuzzy neural network works. And then here for the intelligent control, the advantage is that you don't need to have the moral information, and they are like really good for the handling with the uncertainty. And when there's a fault also, they can either provide the fault elimination technique, or maybe you can use this reconfigurable control where you actually completely fed back the new rather than tolerating this fault and provide the adjusted control output, you provide the whole new output for that, control output for that. So this is like the second part of this. And then once you deal with this thing, you can definitely monitor your system. So this is how you do the health monitoring of your a whole controller and then the overall system. So this is like another approach of controlling the various robotic system. Then I've mentioned about this condition monitoring and lot. So when you do this condition monitoring, then there's like you have to use this machine learning approaches. And when you talk about the machine learning approaches, then you have this unsupervised learning method, supervised learning method, and the reinforcement learning method. Now, in unsupervised learning method, you will be having the data but not labeled. So it will just classify the data based on the same kind of pattern. So that's like good for like, but in the sense of that you can handle any kind of data. But you don't know what kind of classes are there. So that's the problem with also. But then the good part is that you can just take any kind of data, but then you don't know. So but the supervised learning is something that you should label your all kind of data. And when I'm saying the different kind of data means like if I'm injecting a fault in some system, and it could be the actuator fault, it could be a process fault, it could be a sensor fault, any kind of fault, then you should know like, okay, I'm injecting this kind of fault and this will have this kind of behavior, and I'm labeling this fault. So that once you develop or gather this all data, then you can directly just use this supervised learning method, because then you have the labeling of it and then it will classify perfectly. But for that you need to have the whole information about the system. So that's the limitation of the supervised learning methods. But then we have this reinforcement learning. So in reinforcement learning, you have this state, your action, and your reward. So in this case, you don't need to provide any kind of labeling. It's just your agent or your actor is directly deal with the environment. And when it deals with the environment, then it sees like, okay, when the feedback is going back, how is the behavior of it? Is it able to reach its desired in a proper way or not? If not, then it will generate a kind of reward. And if its reward is good, then it's the positive output, and if it's not, then it's the negative output. So it's basically learned based on the experiences. So that's how this reinforcement learning works. Then when I'm talking about this fault detection and identification and generating a lot of data, then you must have the information about the different components which you are considering and how exactly you are gathering the data from there. So like if the motor fault is happening, then how the data is, how exactly you are injecting your motor fault. When you are talking about the navigation system, then what is it like your some sensor or GPS is not working, you can inject like intentionally, you can make some readings or something different, and then so that you can inject the fault in that. So these are the like different components of it, and in that sense you can actually gather the data and use to classify your algorithm, and then develop the fault tolerant controller or do the condition monitoring. So I'll try to explain all these things in this by this block diagram. So what you do generally when you have your system and you have like all different components, you try to inject a fault in the system, and when you inject a fault, you have like this long data. It could be, as I said earlier, it could be anything. It could be from the motor, it could be from the plant, it could be from the some sensor is not working. So any kind of data, you have like this lot of data. But again, because I'm using here the supervised learning method, so it will be having the information about it, like what is the kind of data, so that I can label it accordingly. So once this data is gathered or generated, then you will do this data pre-processing. And for doing this data pre-processing, you will be using this DWT, which is a discrete wavelet transform method, which basically convert your data into the low domain and the higher frequency domain and the lower frequency domain. So, and then once it does that, it will provide you different kinds of features. Now, what happens once you do this, then this data is coming from so many things, and they are like sometimes the same kind of features you can get from the actuator failure. Sometimes you can get the same kind of features from the plant failure or something like that, then there must be some kind of redundancy in the data. So to remove that redundancy, you use this feature minimization method. And in this feature minimization method, you use this principal component analysis. And then using this principal component analysis, you keep the same kind of data, and whatever is the redundant, you remove it, so that when your algorithm train it, then it does not do the same kind of thing again and then do the false training or the false testing. So that's why it's very important to minimize the redundant data. Once it's done, you use this machine learning methods as these. I mean, I've used this support vector machine or like SVDD, MLPN, and there's like so many supervised machine learning algorithms. You use this, and then they train the data, classify your model, and once they classify it, okay, this kind of fault is happening, and in this particular component, this fault is happening. So this is how your condition is monitored, and this information is then set back to your reconfigurable controller. Now the reconfigurable controller is something that will generate the new control action rather than trying to adjust the previous control input or control output that is going to your system. So this is your control output works, and then your whatever your robot is on the field, that you can actually control, and then you can find the condition is safe or not. So this kind of information, you can do that, and you can finalize the safety of your controller or your drone itself. So the next, I have worked with reinforcement learning a lot. Even now I am working with that. So in the reinforcement learning, as I have said, its main thing is like state, agent, your environment, and your reward. So you just need the environment in which your robot is, and what you have, like you have so many different states, and based on these different states, your agent will take an action. They'll choose that which state is what, and then they will send back to your environment. Like when you are talking about the velocity and position, then which particular velocity and which particular position is correct to deal with this defined, or like whatever your responsible output for that they have defined, and then they send back to your environment. Once it's done, then the environment deal with your actions, and then it will be generating the reward. So as I said, like it depends on the error that is generating on your input. If this error is fine, then it will give, or like less, then it will give the positive reward. You set the rewards value already, like if it's in this particular range, the reward will be like this. If it's in this particular range, the reward will be some constant value or some values, it depends. And then it will keep doing the same thing again and again and again, and then it will be learning your system or your controller both. So there's like so many different approaches, starting from the Q learning, SARSA, deep Q network, and then we have these deterministic policies also, and they all are having like the different kinds of labels.
Sorry to interrupt you, ma'am.
Yes.
We are running short of time, so can you please conclude?
Okay. So this is reinforcement learning, and then the DDPG, as I was talking about earlier. And then I will talk slightly about my current work actually, which is on the this grasping of the dexterous hand. So earlier it's like I was dealing with the RL, with the different kind of controlling of the drones and the AL vehicles, but now I have moved to this dexterous hand, and this dexterous hand is like quite complicated because in general, when you deal with any kind of manipulator, then you will be having only some, let's say, 4 joints or something like that. But when you are dealing with this dexterous hand, then you will be having like 24 joints. And see, there's like 20 degree of freedom. So controlling this is like very much challenging and very much complex, I would say. So I'm actually working with this to try to control to do this by using the reinforcement learning. And the main idea is to find the different grasping methods. Like generally when you grasp any object, you will be try to get all the sensing data from the grasping, and then you do this you have this information about the pose and the position and then the rigidity and what kind of texture it is. Then it will figure it out what should be the grasping strategies of it, because there's like so many different grasping strategies has gone till now. But then there's like form closer and force closer is old one, because they are like trying forcefully grasp something. But then if you have the learning network and the probability model, these are like they go and they don't do the forcing, they just try to pick it up, and then if it's not possible they go back and then do it again, and they'll be having the information about it. So this is how this grasping with the dexterous hand is working. Now it should be like very precise, because if it's not precise, it will be precise control, then it can break the things, it cannot hold the things. If you are holding with some kind of grippers, then it two grippers, then it will be equally holding all the forces. But when you are dealing with the hand, then it's like holding like this and it will fall down, right? So you need to have like very precise controlling with these kind of robotic systems. And then recently people are mostly working with the demonstration, so they develop the demonstrations and then they do this they already do it like in real, and then record the video and record the data, and then they use the RL to do this kind of stuff. But then I'm like currently planning to do it with directly, so manipulation and everything without using any kind of demonstration. My whole thing will be done with the hand itself rather than having some base information or like previous information. It's quite complex work, but yeah, that's what I'm recently working with. So I try to do it short. So this is the basically summary. I've worked with like different control techniques and recently working with the dexterous robotic hand, starting from classical control to this RL, and this is like really nice to do all the work by the machines directly rather than doing it on your own. That's the target of doing so. So yeah, so that's it.
Okay, Dr. Rupam, thank you very much. I'm Dr. Tiwari speaking here, Dr. PM Tiwari.
Yes, sir.
Okay. So it was very informative talk, and in fact, you have shared with us robotic related issues, right? So it is very important topic nowadays, because everyone and every government and industry want the less human intervention, right?
Yes,
so
yes.
the places where the human cannot reach and we want to save the human, we want to use the robot, right? And when we are sending the robot, then the controlling should be precise, and preciseness will come when there is an intelligent monitoring, right? So these all are the very important issue that you have highlighted. Fault tolerant also issue, and that comes when we are talking about the closed loop control. Actuator faults comes into the picture. So that all you have narrated. I have just one query, that while doing you these all the controlling issues, solving the problem, whether you are doing you are considering this as a flexible body, or you are doing the modeling with considering it a rigid body. What you can say that? Quick answer.
It was like the solid body or the rigid body, not the flexible one, because we are directly dealing with the robot that is operating on the field, right? So that's the exact replica, or you do the exact mathematical modeling of the system that is on the field. So we deal with that rather than the flexible
So
bodies.
you do the considering this as a fixed body, and then what kind of there might be some error maybe coming preciseness. Is it? Yes.
That's true. That's true. Because whatever you do in your simulation is not exactly work in the same when you deal with the robots in the field. So we always keep it like ratio of acceptable error. So when it's like the acceptable error is within the range, then it's fine. but yeah, exactly, we try to get in simulation like 100%. If it's in the simulation it's 100%, then it will achieve at least 95% of the result when you are dealing directly with the hardware. So that's how you are like get it the exact output.
Thank you very much for your response and attending this conference. We look forward to have a better association, collaborative work with your department in future, right? Thank you
Yes,
very much.
we would like love to that. So
Thank you, ma'am, for enlightening us with your insights into the fascinating world of robotic systems and intelligent monitoring and control. Now, let's continue our journey of knowledge and innovation with the seventh invited talk on recent advances in renewable energy and electric vehicle technologies by Dr. Surendra Reddy Salkutti, Associate Professor at Wusung University, Daejeon, Republic of Korea. Before we commence with Dr. Surendra Reddy Salkutti presentation, let me take a moment to introduce him to our audience. Surendra Reddy Salkutti is working with Wusung University, Republic of Korea, as an associate professor in the Department of Railroad and Electrical Energy since April 2014. He received the PhD degree in the electrical engineering from the Indian Institute of Technology, Delhi, India in 2013. He was a postdoctoral researcher at Harvard University, Washington, D.C., USA. From 2013 to 2014, his research interests include power system restructuring issues, smart grid development with the integration of wind and solar photovoltaic energy sources, battery storage, and electric vehicles, demand response power system analysis, and optimization soft computing techniques applications in power systems and renewable energy. He has published two edited volumes with the Springer and more than 250 research articles in peer-reviewed international journals and conference proceedings. He has served as or is serving as a guest editor for various international journals. He is also an editor board member for many journals. He is the recipient of the 2016 Distinguished Researcher Award from Wusung University Educational Foundation, South Korea, and the POSCO Power System Award 2013. He is listed in the top 2% of scientists published in a study conducted by researchers of ICSR Lab, Elsevier BV, and Stanford University, USA. He is a member of IEEE and IEEE Power and Energy Society. I would like to invite Dr. Surendra Reddy Salkutti to share his expertise and knowledge with us. Please, sir.
Yes. Thank you so much. Thank you so much for introducing me. Good evening, everyone. So I hope everyone is having wonderful experience during this conference. I congratulate all the organizers for conducting this conference, and it will be very much useful for all the participants. And also, I thank all the organizers for inviting me to deliver a keynote here. And also, coming to like today's presentation. So let me share my screen. Yes. So coming to like today's presentation. So I made this presentation in such a way that it will be useful for all the participants, because in a conference, so you will be seeing like various various participants with different research backgrounds. So we cannot concentrate on one topic. So I made a presentation such that it will be useful for all the participants. So those who are working related to electrical engineering. And so as I hope like my schedule is like 30 minutes. So I will try to finish like within 30 minutes of time. Yes. So like now, as I said, like the topic is like recent advances in renewable energy as well as electric vehicle technologies. So as you know, now the renewable energy and electric vehicles are growing like rapidly. So we need to develop like new technologies and new optimization techniques to integrate more amount of these hybrid sources into our electrical power system. Now coming to this outline of this presentation, so I'm going to first start with some introduction. Then we are going to see like importance of renewable energy as well as electric vehicles. Then we are going to see how we can model these sources in a hybrid power system. Then we are going to see various optimization techniques, how we are going to solve and how we are going to use them in a hybrid power system. So coming to a general topic like smart grid. So as you know, so most of the countries, they are moving towards the smart grid concept. So it is due to, there are like several advantages. So in a smart grid, as you know, it will be useful for introduction of like introducing electric vehicles or wind energy, solar energy, as well as energy storage. So this will be useful to incorporate various concepts like introducing electricity markets as well as demand response, and it will be like self-healing. So all this we can achieve by introduction of this smart grid into our existing power systems. Now, as we know, so we need to know why we need renewable energy. So this is a basic slide. So it will be, you may be knowing this, most of contents of this slide. So because the demand is growing rapidly, and also where the fossil fuels like coal and oil, they are depleting very fast. So, and also we need to meet the existing or emerging demand, so in an equitable and sustainable manner. So to overcome all these difficulties, so we need to go for the renewable energy. So like as you know, so every country, so they are keeping their targets to meet the percentage of renewable energy that they are going to introduce or incorporate in the every year. So they have the target for every year or each 5 years or 10 years time frame. So like that, every country, even the Denmark, they set as a 50% by 2030 and 100% by 2050. So like that, every country, they have their own targets to integrate renewable energy sources into the grid. So now coming to this main problem with renewable energy sources, like maybe wind power or solar power, it is mostly due to the uncertain behavior. So this is because of this uncertain behavior. So there are going to be like many challenges to the power system operator. So power system planning may be difficult, maybe operation may be difficult. So we have to develop, or we have to keep the plans such that the system operator can overcome all these planning or operation issues. So as you know, there are various sources of renewable energy sources like wind energy or solar energy or maybe biomass, geothermal, hydrothermal, hydropower, or tidal or wave energy. So we will be having various sources of renewable energy sources. So most of the sources now we are concentrating on the wind power or solar power because of their large scale existence, and then new emerging technologies to incorporate them in the our power grid. So this is about like various sources, how we can generate power from the wind or the solar, either hydropower or the biomass. So this slide I will skip. So this is introduction, like how we can incorporate or how we can introduce these sources into the power grid. Now, as I said, like we will be having like various components in a hybrid power system, because previously the power system, the conventional power system, we don't have much complexity. So the traditional power system was very simple and easy to manage or easy to optimize. So but due to the hybrid power system, so because of various components, so it is very difficult to handle, and the power system is structure is now become complex in nature. So like you will be having like smart villages, smart cities, smart homes, and Then recently introduced concepts like battery storage or electric vehicles. So whenever you will be having electric vehicles, you will be having you need a requirement for the installing charging stations. So all these are the new emerging trends in our existing power system, which are making power system like more complex in nature. So to overcome these issues, so we have to make a proper plan, a proper schedule, so that we are going to research or we are going to make some improvements to the existing research. So as I said, we will be having a hybrid power system. In a hybrid power system, we will be introducing renewable energy as well as energy usage. So we have to do optimization of all these hybrid components. So you will be having various components like renewable energy, so bidirectional EV charging. So maybe the charging, maybe discharging. So it will be like a vehicle to grid or grid to vehicle modes. So we have to concentrate on both the directions of power with electric vehicles as well as the battery storage. And also now every government, so they are moving towards the smart homes and smart buildings as well as the smart cities. So this hybrid system is going to introduce complexity to the power system. So making our power system as a hybrid power system. So as I said, the main problem with renewable energy is going to be like uncertainties related to wind power as well as the solar power. So because these are going to be like larger portion is from the wind power and the solar power. So two main issues are going to be like variability and unpredictability. So these are the main two issues with the renewable energy sources. So to overcome this, we have to use in the practical world, we have to use some probabilistic models because to handle these uncertainties. So there are various ways of handling the probabilistic nature, because if we have like a good forecast, then we can overcome some of the problems related with probabilistic analysis. So whenever we have these like volatility or intermittency or unpredictability, so this is going to create a random, so more randomness to the existing power system data. So this is going to be handled by the system operator. So it is going to create great challenges to the system operator. So whenever we have, because some of the researchers may be working, how we are going to incorporate, how we are going to integrate wind power into electricity markets. Because when you generate more wind power and more solar power, there must be some way to integrate into the system. Because we cannot integrate wind power, solar power as much we generated to the system. Because in a thermal power, you have an option, like you can choose in what time you can generate how much wind power, how much thermal power, hydropower, and you can feed into the grid. But whereas renewable energy, there are like less chance. You cannot generate whenever you want. So you have to make a proper plans or proper procedure how you are going to incorporate or integrate wind power into the system or solar power into the system. So further, so those who are working in a related to electricity markets, so they can think about how you can handle or how you can integrate wind power or solar power into the system. So there are basically two ways how you can incorporate into the system, like non-market based approaches or market based approaches. So generally in India, we use a non-market based approach. So like we fix some tariff to the wind power or solar power, and then we are going to use all those power into the grid, because we don't have sufficient wind power and the solar power for the time being. But whereas the countries, those who have sufficient amounts of wind power and solar power, they can choose market-based sale. So that means they can go for the market like a wind generator, like thermal generator, and then they can bid into the market, and then they can fix the market clearing price. So this is a two ways how you can integrate wind power or solar power into the system. But now, apart from the electric renewable energy, now all the world is moving towards integration of electric vehicles, because nowadays you can see most of the countries, so all the new vehicles are now electric vehicles. Of course, the cost of the electric vehicles for the time being is much higher compared to regular IC engine vehicles, but still in the future, so emerging technologies, the cost is going to be definitely down. So now maybe this is a general slide, like why we need electric vehicles, like due to availability of the fuel. So we don't have sufficient fuel, so we must depend on the Middle East countries for the fuel. So this is one of the reason. And another reason is no pollution. So when you use all electric vehicles, 100% electric vehicles, then CO2 emission will be like only 50%. That means 50% of CO2 emission is from only vehicles. So when you use this renewable based charging, so the carbon footprint is going to be reduced drastically. So this is one of the reason. And another reason, like capital and maintenance cost. So of course, the EVs has more capital cost, but the maintenance cost is almost zero. So when you use a solar based charging, so because of all these reasons, so everyone are moving towards the electric vehicles. But now you can see, compared to electric vehicles, electric cars and gasoline cars, so gasoline cars, like you will be having the emissions and also, but mileage is little more compared to electric cars. But now, due to the recent advances in the battery technologies, the mileage is increasing very much. But of course, charging it takes more time, but still now, due to fast charging stations or fast charging technologies, the charging time is going to be less. But the maintenance cost is going to be very low compared to gasoline cars. So, but when we see like a cost for this, both the vehicles are going to be almost same when we use electric vehicle as well as a gasoline vehicle for 5 years time. So when you use the initially the cost is very high for the electric vehicle, but when we use it for the 5 years time or maybe 6 years time, based on the fuel price in the particular country, so in 5 years time or 6 years time, so both the cars, the cost is going to be same. So this is one of the reason, so why we can use or why we can go for the electric vehicles. So still now I said why we can go for the electric vehicles. But whenever we go for the electric vehicles or when we integrate electric vehicles, we will be having a lot of challenges. So because one of the challenge is going to be same like renewable energy. Because like renewable energy, like wind power and solar power, even electric vehicle load is also uncertain. Because we don't know when the electric vehicles are going to be charged, when they are going to be discharged. So because of this reason, so the electric vehicles also going to introduce intermittency or uncertainty into the system. So same like renewable energy sources, we also have to handle the uncertainty related to electric vehicles. From uncertain point of view, this is, and whereas grid operation, again, when we integrate large number of electric vehicles, so we need to consider the grid stability also. So this is not a problem. So these are not the problems, but these are going to be some of the challenges. So which the system operators or the researchers, they need to work on these areas. So those who are working in this research area, so they can work grid operation, including the stability. So this is one of the research area. And another research area is like optimization, including intermittency or uncertainty. So these are the research problems related to electric vehicles. Now coming to ancillary services, like energy and ancillary services, because when we have large number of electric vehicles, we must have some kind of supporting services, because when I introduce a large number of wind and solar into the system, now I don't have sufficient ancillary services, then system is going to be collapsed, or system stability is a problem. So for that reason, we must have sufficient amount of ancillary services, and that we have to support for the system. So if you don't have the sufficient amount of ancillary services, the system is going to create stability problems, or maybe even it may be blackout. So to avoid those problems, the system operator must have sufficient ancillary services in the system. Or if no ancillary services, then we have to shut down the power. That is load curtailment. So load curtailment is not a good practice. So we have to have sufficient amount of ancillary services in the system. So here you can see, so you will be having an aggregator for electric vehicles, because I'm a single electric vehicle owner. I cannot go to the market. I cannot bid in the market. So we have to have several charging ports. So charging port 1, charging 2, 3, like that. You will be having n number of charging electric vehicles. So all of them together can make an aggregator, and then he can participate in the energy market as well as the ancillary services market. So because, as I said, we will be having different types of ancillary services to integrate into the system. So therefore, we must have some kind of ancillary services, including frequency response or energy balance or operating reserve. So these are all like different types of ancillary services in the system. Now, as I said, we also have some kind of demand response. So demand side management, because when you have large number of electric vehicles and large number of wind power, solar power, we must have sufficient demand response management. So we must have sufficient amount of demand side management in the system. So whenever you have demand side management, so you can see even a big company or the building can participate in the demand response, or a small house even can participate in the demand response, and all electric vehicles, because they have the battery, so they can also participate in the demand response. So because the demand response is going to help us to secure the grid. To secure the grid, so we must have proper demand side management in the system. So there are various options like to have demand side management, like you have embedded generation, like distributed generation or mobile generation, or customer response. So even I'm a customer, I can respond if whenever there is a demand side management or demand requirement. And energy storage can also possible, and tariff strategies. So you must make a tariff strategy so that every customer must he can, like, even without demand, he can freely participate in the demand side management. So now coming to ancillary services optimization, so we can optimize both like energy and ancillary services together. When you do this together optimization, so you are going to get a best result. So like energy and ancillary services management, you are going to have a best energy market, best reactive power, and best reserve. So when you do this kind of optimization, you are going to get a most economical dispatch, so from each single generator. So therefore, when you do the joint optimization instead of individual optimization, you are going to get a better optimal solution. Now, those who are working in the problems related to electric vehicles, they can think about this kind of problems related to electric vehicles, because nowadays most of the researchers, they are working integration of large number of electric vehicles into the system. So these are all different optimization problems related to electric vehicles. So, so researchers, they can work in optimal location and sizing of electric vehicle charging stations. So because we don't know, so because till now in our cities we don't have a suitable location or suitable size of charging station, same like a petrol station or gasoline station. So, and also when you have parking lot owner, so because when you have electric vehicle charging station, the owner also must get his benefit maximization. So those who are working for the each charging station point of view or parking lot owner perspective, you can also work and also maximize aggregator profit. As I said, aggregator is going to collect the all electric vehicles together and is going to participate instead of you or instead of a single vehicle owner. So aggregator also, you don't do it for the free. So he will maximize his profit and also minimize EV charging cost. So we have to minimize the cost. This is also one of the objective. And also minimize operating cost of the system and maximize revenue or social welfare of grid operator. So all these are the different objectives you can think about when you do a research related to electric vehicles. So these are all the research problems related to electric vehicles in terms of power system optimization. So people, those who are working in electric vehicles, they can use these one of these problem and you can work your research. So as I said, you will be having optimal allocation of hybrid power system. So you can allocate because previously you used to allocate renewable energy based DGs or network reconfiguration or STATCOM allocation. Now the topic is like allocation of electric vehicle charging stations, because this is one of the emerging area where you can see electric vehicle charging stations together. So simultaneous allocation of DGs, electric vehicle charging station, and network reconfiguration. This is one of the problem you can think about in a hybrid power system. So this is also one of the problem related to electric vehicle charging stations. So whenever you have electric vehicle charging station, you also need to model electric vehicle in the power grid or power system. So this is a traditional power corporation. Now you will be having the charging station. So in a charging station, so you will be having the storage system. So other charging pile, from this charging pile, you are going to charge or discharge to the system. So that means for a power system point of view, you have to think when your system, your electric vehicle is charging and when it is discharging. So we don't know when it is going to charge at a particular time and we don't know when it is going to discharge. So this is going to create uncertainty to the power system. So that means electric vehicle load is going to be uncertain. So we have to handle this uncertainty because electric vehicles users, so we don't know when they are going to charge and when they are going to discharge it. So those who are working in a power system point of view, you can think of modeling the electric vehicle based on this equation, because every electric vehicle you will be having the battery, so you will be having the initial charge and then the charging or discharging you can model by considering this exponential function. So every electric vehicle, the power at any particular time you can determine at any instantaneous time, you can determine by using this particular equation. So there are different ways to model electric vehicle. This is one of the basic way how you can incorporate into the system. So I said you will be having whenever you have electric vehicle or wind power or solar power, there is going to be some uncertainty. So whenever you have uncertainty, you need to model it, because in a power system you have to model every component. So to model this uncertainty, you can use some probabilistic based approaches. Now coming to probabilistic based approaches, you will be having different approaches available in the literature. So you may have numerical approaches or you may have analytical approaches. Coming to numerical approaches, you will be having the Monte Carlo simulation approach. This is a very famous approach to handle the uncertainty. But in a Monte Carlo simulation, the main problem is it is going to take more number of samples and you need to have more time. So to avoid this, so we are going to have different types of analytical as well as technical, numerical, and analytical approaches. So like this, you can model electric vehicles in the system, and this is one of the electric vehicle charging station in our city. So it is an online electric vehicle. So this is in our near to our institute, that is a KAIST institute. So those who are working in a power electronics point of view, you can think about using this. So, okay, I'm going to conclude. I think you have less time. So, this is one of the electric vehicle charging station in our city. So it is operated by Hyundai EV station. So as you know, most of the cars, so in Hyundai or Kia cars, so they are most famous in cars also in India. So they are manufactured by Korean company. So in our city, we have all these charging stations. They are operated near our universities and near our city. Okay, so short of time, yes, I'm going to conclude this, yes. So this is how you can model wind power, solar power, or batteries. So coming to the conclusion, so this is a presentation where we saw how we can model electric vehicle charging stations, and wind power and solar power. So these are the some references. So I'm going to stop presentation now. Thank you so much for your kind attention and patience listening. So if you have any questions, so you can write to me. My email surender@wc.ac.kr. So okay, with this I'm going to conclude my presentation. So yeah, please let me know if you have any questions about this.
Thank you, Dr. Reddy.
Yes, sir. Thank you, sir.
Was a wonderful talk by you on renewable energy and EVs, and you have talked a lot about the penetration of renewable energy into the grid. Though there are lots of challenges like integration of renewable when it is integrated into the grid, then because of its low inertia, we have problem of frequency control, like stability of the system is there. But I mean, with researches going on, it is being overcome, and other aspects like V2G and G2V, this bi-directional converter is also there. So the challenges are there, but I mean, with the improvement in the research, it is being done. And the research scholars also they are going to get benefited from your slides. You have shown the modeling also, the EV modeling also you have shown. So I think the talk was wonderful, and we will like to connect with you in future also. So thank you.
Yes, sir. Thank you, sir. Thank you so much.
So thank you, Professor Reddy, for joining in this conference and giving your very informative talk. I am Dr. Tiwari. We will be in connect in future also, and we will use your expertise for various purposes like joint collaborative project and joint PhD guidance. And already with you, Dr. Divya and Dr. Viral is already connected. So it will be easy to reach you very easily and reach with all the kind of support. I hope that you will be available also. So thank you very much, and nice to hear you, and goodbye for this evening.
Yes, sir. Thank you, sir. Thank you so much. So thank you, sir.